Yeah, I need somebody
You're
to back
quoting
me up on
somebody.
this.
I
No,
think
I
you're
can't really
quoting
talk right
somebody,
now,
but
but
what you're
it did
saying
detect. It
is
did detect the friend shifts proportionate to sidereal rotation, so it did detect the ether drift. So sit down.
Yeah, which way? Which way was it?
Which way does the sky spin?
Oh, it should be in the numbers. I mean, there's in their report or something. Something should report this is what we detected, and I
It
think we
did.
could
It did.
refer to that.
Yeah, yeah. In the original
Other,
MMX paper, it talks about detecting a friend shift.
okay, I don't know.
They just classified it as null because it was below what they predicted. It was 1/6 what they predicted.
Yeah, they absolutely
I
got a
mean,
friend shift.
I can't go into like a big convo though. I'm chilling with the fam. You
No,
guys
it's
have
fine,
fun
dude.
with that.
That's all I needed. Just all I needed, bro. Thanks.
In the original paper, they said they wanted to do it again on top of a mountain because they assumed near the surface of the Earth is static. There's like a, what do you call it, boundary layer effect. So anyways.
Imagine walking into a room and seeing the lights move on the ceiling, and then spending the next 200 years trying to equate that to the floor underneath you moving.
Oh, that's another thing too, bro. You guys brought up the red shift and blue shift. How would that look? Right. From a geocentric perspective, how would that look with the moving substantive background medium all around us, right? And then you're interpreting what you're seeing as red shift or blue shift, talking about the age of the galaxies, the age of the universe, based off of red shift and blue shift. This is all assumptions, extrapolations. Because the blue shift could be caused by the medium itself. It's just like light in the think about light, how it at sunset, right? You get the red shades, the red hues, the orange hues. Why does that happen? Does anybody know why that happens?
Yep.
And why you get blue, you get, even photographers, they know the frequency, like the blue and the reds, or the 4Ks, 8Ks. That's light attenuation. And the reason that the red hues are able to persist longer than than the blue hues or the blue frequency waves is because the red frequency waves have a longer wavelength, so they travel further. Like bass travels further, so they can penetrate.
You talking about
Yeah, they
phase
can.
cancellation?
The red phase can penetrate longer, right? Even if they originated from the same point as the blue, right? They have more penetrative power. So if everything is moving, and then you have a cosmic ocean that surrounds us, some would say, a background medium, how would light interact inside that medium? And what kind of light attenuation would you expect? And if that medium is moving, it's just going to complicate things. These guys are making assumptions.
So yeah, it's weird that actually the sky, the blueness of the sky is polarized light. I find that interesting. Like, I'm not even sure by what process it actually happens that it gets to be polarized.
The firmament.
Some type of process, which I think is like some kind of birefringent material or process, like needs to be in the process to polarize it. So I'm not certain if that couldn't be like some type of medium that's in the middle of it, doing that. But then that medium would be responsible for any kind of frame shift that you would detect from anywhere we go to take pictures.
That medium
Yeah.
is a prerequisite for anything.
We can say that something has to be polarizing the light to make the blue sky a polarized light source. And for these reasons, photographers know that certain times of day favor photography more than others, because of like the blueness of the sky will actually kind of interfere with the photographic process. So, yeah, like golden hour, blue hour, like early morning, sunset, But these times have their own kind of color temperature, right? So we don't get like a blue sunset, We might have like a red sunrise though, but to what reason that we get that color signature out of there has got to be due to like atmospheric changes, whatever your du jour atmospheric situation. If that's not too fancy for you. Too fancy? Is that French?
There's a viewing gallery for artwork that some architect designed. And he designed it so that he could take advantage of the effect that you get from northern light, but at all times of the day. So he's got like these curved roof windows that are designed to keep it the same color temperature, like you were saying, throughout the whole day, so that the artwork is appreciated the right way.
Okay, like adjusting LED.
Yeah, but it's not. It's mechanically adjusting the light, the natural light.
Wow, that blows my mind.
You guys get the light attenuation parallel, how they interpret blue and red spectrum, because the further something is, right, the light would get attenuated in a medium. You would end up with only red spectrum.
In attenuation,
Understand?
are we talking about like signal transmittance?
Both.
Like
Both.
like
It's
the
relevant.
reason that
Yeah.
like like there's that green aftershock or whatever like some people see in their eyes, and then we also
That is
can get like that
interesting.
green glow. But they say that is due to the cutting off of the electro-optical signal, which is light. Light being, I guess, equivalent to some type of moving electricity. But like, I don't want to
Flickering
get
off.
into a discussion with that. Man. Like, if we can draw electricity, like, two thin films of different material, and if plants can like basically draw most of their sustenance from it, yeah, like there must be energy contained in the light, right? So like it's part electric. The reason that photosensors work, and the reason that, like photosensitive chemicals due to electro-optical chemistry that's going on, and also right. So like either we have to make something that's going to respond to it and then form a picture that we develop, or we need like small particles that we can like affix to a sensor array, you know what I mean? And then, but they have to be responding to these different like light frequencies. So all these types of there's a deep amount of science in here, really. Honestly, there's like only a couple companies that really know this shit that are like at the top end of sensor development. And all that. The attenuation, the break off of it, they say that surge is what creates the green after effect in your eyes, and it's a cutting off of the electro-optical signal.
I've seen it, like pictures of it though, at sunset. There's like a green flash or something on the horizon. It's kind of weird.
Mm-hmm. Yeah, it'll happen to certain cameras, and it'll happen in the eyeballs too. Because light's working the same way. Like light doesn't change for how a camera. Like it's just different hardware setups.
The green spectrum is right in the middle, between blue and red. It would also be eventually diffuse.
It's like like if I was to unplug my microphone, you'd hear like a that's just like there's an overload, and that's basically what you get as you unplug something quickly. You get like a negative kind of shock or something like that. It's almost like an optical static shock is occurring as it leaves your eye, because it's a very strong light. Like it's beyond a regular like street lamp. I don't think you get that same kind of effect if you just have like a man-made light and you thing. It's just a very strong light, man. Sun's really strong. I'm just like, I find it like amazing, like being somewhere on a plane where everything was dark, like it was nighttime, and then breaking up through that cloud layer and discovering that though it should be nighttime by my clock, and it is nighttime on the ground, to the reality of everyone on the ground above there, still a light, so much so that you would sunglasses hang out up there.
Yo, is the redshift guy still in here?
Yeah.
Talking about me, dude?
No snooze, I guess. Here?
No, the Glober,
A
the guy that
guy-
used it as evidence.
A guy is deafened
For-
and
But you could tell us about it, dude. If you want to share with us.
I mean, I wanted to kind of start destroying them, but it's okay.
hey, sorry,
Kind of I'm
Save
a
it
little
for
rusty
later.
on this.
what you think, man? Like,
Oh, I mean, we can talk
think
about
that-
it though.
hold up.
Fucking shreds it.
But
What up?
on Redshift, man, like, do you think that the differential or whatever the combined motions of the Earth should result in redshift that is visible from the ground?
Yeah, the Doppler redshift sounds great. Okay.
Yeah.
But when they observed it, they so that's what I want to talk to that guy about. Quasars, so not all of them, but certain quasars, they would redshift in quanta, in steps. It's called quantized redshift. And these guys used it to destroy their cosmos, like the universe is gradually expanding. No, it's not. Because it redshifts in steps. Like who can explain that? Why is it redshifting in discrete steps? Because like that's not gradual expansion at all. And that just wrecks their theory. And it's like that's just all you need, essentially.
Ooh, that's
For
nice.
it's like
dude.
fuck off. Yeah, it's called quantized redshift. It's like
Yeah, 'cause
explain
it's
that,
it's
bro.
cyclical. It's a cycle, dude.
Imagine if it's like an electrical level, like voltage level 1 to voltage level 2, or whatever it is, however you want to explain it, but it does take discrete steps to redshift. And like no one can explain these discrete steps. It's like, what's that? How's that working?
Yeah, because there's retrograde motions, there's all types of motions, right? That when you start including this background medium, when you start interpreting these observations with the premise that there's a dynamic background medium, then the red shift and the blue shift makes sense because you have these swirling motions, these swirling vortices of just a cosmic ocean, dude. Like it's a cosmic
It's a real
ocean.
thing.
And that
Like
and,
the
and then
redshift
the light that's traveling through that, right? When we observe it from our reference frame, if the whole sky is moving towards us, it's gonna blue shift or it's gonna look blue. Right? If the sky is moving away from us, it's gonna look red. And then it's gonna make
Like-
its move. It's gonna yeah.
It kind of
Depending
to
on-
me like has those general qualities just in sunrise and sunset. Like it's more rare to see like a red sunrise, a bluish light, and especially too because like it's at its like furthest from you, and presumably like that air mass that it's cutting through is like cold, and it hasn't been like fluffed up or something like that. It's had the whole night to like compress down, like to take all the available space electrostatically, and to it would be at its maximum absorption. So like when it starts to be broken up by the light of the sun, because that does happen. It, like the sun warms up stuff, and then and then it can kind of like splay out a little bit more. But I don't know, man. Like I find it the general quality of the the morning is like blue. I don't know what you think. If you take like 10 o'clock, and maybe it's different, but I'm talking about sunrise and sunsets. But hey, A guy's back. We can argue with you about
Yeah, it would be blue. It
shifts.
would be blue because the sun's moving towards you versus the sun moving away from you. And
There's
that's
all
sort
this
of like
junk
how.
between
how
you. Yeah,
yeah,
sorry.
sorry, go ahead.
There's just all this
Pressure
junk.
opposed to negative pressure.
There's all this mass between you and the sun getting in the way, and like basically like you're in a type of waveguide that's composed of atmosphere, if you like, just air, whatever different air masses are in their densities, in their forms, right? Because we could talk about atmosphere, it could be clouds too, right? So that's going to like create like these diffuse effects, you know what I mean, that are going to like minimize the polarization of the light that you would see from a blue sky. If you don't see a blue sky, then there's a possibility that the light generally around you is not very highly polarized.
I have no idea what you guys are talking about.
That's all right. Why don't you talk about red shifts with the other guy? Syrus, you're on deck, sir.
Oh, it's all good, man. I don't think he was the same guy, so
Round
it's
one.
not fair.
Fight.
Let's
It's,
go, right?
redshift. That's that's the inflation. The universe stretching.
That's a nice story.
Okay. Start again. Round one. No.
Yeah.
Sure.
Sorry. But I think we need to have some. If you're gonna talk about it, I think you need to have some ground, like to discuss something. We need to discuss something that's actually observed. If you don't think it's observed, the redshift at all, then I don't really see there is like nothing to discuss about
Okay.
why it's.
How about
redshifted.
this?
A guy.
I am
A
totally
guy
with you, man.
Cyrus. Go.
No, it's not versus. We're discussing,
Alright.
bro. I don't know the man. We don't.
Can I throw a monkey wrench in
he
here?
wants. No, hold on. I got
Okay.
one real quick about redshifts. So
It's
let's
still-
discuss about the luminous filaments that these guys observed. Right? He said something that we observe between high redshifting quasars and low redshifting galaxies. Go. Explain
Oh,
those
absolutely.
luminous filaments between the quasars and the galaxies.
What?
Both are redshifting.
Luminous filament. What's that?
That was observed by Halton Arp between high redshifting quasars and low redshifting galaxies. Okay, so
Between
that
high
was
redshifting quasars. So that's quasars that's very far away, and then low redshifting. That means there are closer galaxies. And what did we
Yep.
measure between them? You just say again.
they observed a luminous filament,
I
suggesting
don't know what
that they were
what's a
physically
luminous
connected.
filament.
Light filament,
What's a
like a
what's a
line,
li-
a line of light.
That's interesting.
Yeah.
How do
So
we see
these
what is
guys,
the light
they suggested
filament
that they
look
were
like?
physically connected despite their radically different redshifts. They're redshifting for a different reason, but they're like when
Connected
you
how?
observe it, it looks like they're by light.
I have
But that's what they
like
called it, luminous
How is
filament
something
in
connected by
redshifts.
light?
It's not my problem.
No, I don't understand
know,
what
bro.
connected by light means. I have no idea what that means.
filament. It's like a long thing, like a hair or that or whatever.
Like
But
Yeah, but
I
light
have
is
I
not
have seen
hair.
in my own experience, like during I guess almost 2 years of just like stargazing, like for nighttime, living without electricity mainly. That like
Yeah.
I would see like a series of stars like light up in a line, like bow, 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 and it would be like only for an amount of seconds, I guess, before I would start to notice other kind of lights kind of like lighting up, and then I couldn't tell if there was any kind of pattern to it at all. But like there was like a main series. They're like connected by like a light string or something, like they're on the same circuit, if you like, electrostatic or what have you. There must be some type of like energetic connection between things, and especially like that stars are said to radiate basically radio signals, or so the space telescope people would have us believe. So what I was wondering, and I get back into redshift, was that if there are discrete steps to a redshifting that we can detect, that may be emblematic that there is possibly something like a square wave fucking squiggled into the stuff. Is it have
think
to do
there's
with like
the
possibly
discrete
no, I'm
steps.
almost. But like
Okay.
light and radio are so like they have like a coordination that is causing these red shifts in our pictures and stuff like that, and that the cyclicality of them might suggest it's kind of energetic wave cycle. But we wouldn't discrete steps with if it was a sinus cutoff. I don't know. My guess is that, and it's what I'd like to propose to Syrus. Like, is it possible kind of like square wave radio shit that's going on up there, syncing like these different there are different bands of like radio that are just kind of like in our atmos, right? So like, is it possible that cycle is actually creating this quantization that is creating these like discrete steps, and rather than a gradient? Go ahead.
There's different like options, of course, because we don't exactly know. So let's say if the universe is expanding, let's go with that. Well, it's jumping tracks. It's going from one discrete track to the next one to the next one. There's no gradual anything in between. So that kind of like, all right, you have to explain that. And then you go with the other option that these guys went with. It's called intrinsic redshift. Now, this is the stars. So redshift, you can determine the age of the star by the redshift, not the distance. This is what these guys are getting at. They're also globe Earth cosmologists, PhDs, and fucking everything you need. Okay, and they're saying no, the redshift is intrinsic. It's from the star powering down. All right, and when it's powering up, it blue shifts. So the internal energy level, when it fluctuates, it blue shifts over red shifts. So much weight. That's how these guys explain it.
Is that the new
I
way
like
to
that
explain it?
until the mainstream doesn't like it.
Cycle?
The
You say
mainstream
that
doesn't
it's
like
blue
it.
shifts when it's getting with age. I thought it was the opposite. I'm quite sure it's red.
Yeah, my bad. Maybe, yeah, it's getting redder as it gets older, right?
Yeah, because
said,
it's getting
right?
colder.
Yeah, that's what I said about that one. But I was
Or
saying
it
for the intrinsic
expanded.
redshift, when it's
I thought-
powering up or powering down, it would also redshift or blue shift.
Yeah,
Depends
I
on
might
which way
be
you're going.
I might be an idiot here. I thought that the red shift was detected about things that are moving away. Blue shift is what is
stars
moving towards
have different ages. So depending on their age and their size, they will have a different light spectrum provided.
No, this is not what I was saying. But it's also interesting that we've got like this kind of dipolar, if you will, situation where you've got the flux moving in opposite direction itself. It's like a nature of whatever polarity. Just if you had two stationary things, and you could also conform it to your spinning dynamic universe model if you want to. But we could basically understand that if there is like a magnetic cycle or something like that is at play behind like the movement of the sun and seasons and stuff like that, if there's like cycle of energy, possibly even backed with like what is invisible energy,
Yes.
like the radio and stuff like that. That these stars are supposed to emit. I'm sorry.
Can I ask a question real quick? Has anyone here done this kind of measurements themselves? I mean,
I actually have been part of it. I actually have done it, been part of it. I don't have the equipment myself, but I have a guy now who does also astronomy, and he does a little bit of spectroscopy. It's not very precise, but you can see the lines clearly.
I do have a spectrometer. I do have the equipment, but I never cared to do one. I understand. Like if you have a flashlight,
it's not.
It's not very complicated equipment, actually. It's very simple.
I'm saying astrophotography, bro. Like people, they focus on like 3 CCD cameras and stuff, and you could definitely isolate to just infrared if you wanted to. You can isolate. You can analyze the spectrum yourself at home. It's not like this difficult thing. Go ahead.
It's cheap equipment. Shit. Now I forgot what I was going to say. It's all good. I don't know. Oh yeah, I was going to say if you put a flashlight on the beach, right? The distance between you and the flashlight is fixed, but the battery's dying in it. It's going to redshift. Okay, you can assume that it's moving further away from you, but you would be wrong. But if you assume that the battery in it is dying, you'd be correct. But they're both going to redshift on you. So it's up to you to determine what the fuck is going on here.
Right, and like Snacks was
Make an
saying,
assumption. Like, make an assumption, go with it, try to prove it right or wrong. You know what I mean? If you have multiple options, you're going to have to make assumptions, which is cool. Write them down. Like, I'm going to assume this, then go verify, yeah? Whatever it may be.
Well, they can measure the distance in several ways, but what we do see is that when we have different methods of measuring distance to stars, we also see like with things that we know are further away. We can see with like the size of galaxies, etc. You can see that they're further away. The assumption is that it's a uniform distribution. Like we need to explain why stars would look different further away. Is there any reason why a star would be different? So that's the assumption is that the assumption is that they are similar to what we have around us, and when we compare them, there is a redshift with the ones that are further away. We can say that it's because it's the stretching or whatever, but for whatever reason, it's redshifted, and that needs an explanation. But we definitely, I think that's a better explanation than to say we don't know. Like, I think it's
okay. Wait.
Hold on.
You said wait a minute. You're saying it's an interpretation, correct?
Yes, it is it's
okay. Thanks.
Mm.
Go ahead.
Oh, thank you. No, yeah. So yeah, you're conceding that it's simply an interpretation, but that there's multiple causes.
I don't know
what else
cause
you
there
think
is.
redshift? Hold on. You think redshift is mutually exclusive to only expansion?
I don't know what else could cause it.
Well, you acting like it's mutually exclusive. Oh, well, I don't know.
No,
What
I
else
don't
could
have
cause
any
it.
other. No, I'm not saying it's mutually exclusive. I'm saying I don't know what else causes could do that.
Well, that's why I brought up what Snacks brought up, because there's multiple causes. One cause is that there's things moving towards us versus moving away from us, or right, there could
Then it
be
will be blue shift.
there could be a background medium, right? Now you are presupposing a vacuum. What if the contrary was true, which is what I believe? My worldview consists of us being surrounded by a medium, and that medium has actual effects on the propagation of electromagnetic frequencies, all light. You're assuming that it's completely unimpeded through its propagation in the vacuum of the cosmos, that it could just go basically infinite. And what you're seeing is billions of years old in the past. That's why it's redshifting. And not only is it billions of years old, it's expanding.
The irony being that it's the medium that allows it to propagate in the first place.
Yeah, like that's the thing you said. We assume it's a medium. Like that's the assumption of redshift is that like it's the fabric of space, which is, you could say it's a medium or whatever you want to call it, but we say there is something else than.
Well, I also brought up like your side can also argue for the fact that it's almost like a mirage what you might see. If you saw some redshift, it could be that space itself actually shrunk up, shriveled up, and like caused this optical effect to happen that you thought was redshift, but it's isn't that a bit?
What? Optical effect?
I know. There's outs for every side. Crazy.
No, I mean, what optical effect?
The space-time distortion causing redshift, that space-time itself, actually has contraction, which causes.
Yeah, dude, that's it. Oh man,
you know what I'm saying?
Yeah, but if it contracts, you would expect a blue shift.
That's like saying you didn't pay your cable bill, but so you can't see the stars correctly.
No, I'm saying it doesn't explain a redshift.
Sorry.
That would explain if we saw a blue shift, but we don't see a blue shift.
I'm trying to put this in left lane satellite TV terms. You know what I mean? It would be like if your colors shifted, and it'd be like, oh yeah, that didn't happen. You know what I mean? You thought that should
What about
happen.
What about the option of having the high red shifting intergalactic gas This is all mainstream stuff.
That's
But it
dope
just
too. That's a great
opposes.
out. There's a million like little sci-fi
bro,
outs.
This is not a sci-fi out, bro, but this is by a mainstream astronomer. That he was working as an astronomer, like an observatory, and he just wrote the books that shredded the shit. So it's like, no, that's not what he observed.
Based on interpretation, you forget it.
He's got photographic evidence of these luminous filaments. Okay, all right. Photographic
It's an
evidence.
observation, not a measurement.
Yeah, whatever, bro.
Yeah.
Whatever.
Yeah.
So, have you looked at his
what
work?
it is. An observation is not a measurement.
Just
Sorry to tell you that.
refute
Sorry.
it. Just refute it, sir.
You're gonna ask him to explain something. He's gonna smack you with the yeah game. I want none of that. Yeah. You thought you would say something? Yeah. So anyway, yeah. Redshift. We've got multiple explanations. It seems like anybody could come up with any explanation. This is one that you've got. I'm not saying it's not necessarily like fictitious, and I don't mean people are like trying to come up with fictitious things, but a lot of things, a lot of like natural phenomena in general, can shift light. So, you know,
Exactly.
what the primary cause is, I don't want to put my finger on it just yet. I'll wait another 10 years, maybe. Who knows?
So on Earth, empirically, we observe all the different factors that can affect electromagnetic propagation. We know this, we can observe it, we can repeat it, reproducible, testable, we know this, right? Empirically. Why appeal out of all the things that they could have appealed to rationally, right? Reasonably, that we can see on Earth, right? For whatever reason, they want to act like the universe is expanding at an exponential rate. And that's why, none of these other reasons, you could choose whatever, you know. No, none of those. This one reason, no, this is the reason why we see redshift. It's because the universe is expanding and they needed that. That's another patch that they needed, bro, to make it had to do with the orbital mechanics. It had to do with these spiral arms. If you look this up, why they needed expansion was because of dark energy, dude. Dark energy, they needed expansion. Look it up, bro. It's crazy to get into, but your favorite large language model will help you out with that.
Some quasars redshift in, like I said, discrete steps. Unless you explain to me in your globe Earth model how this works, like, fuck it, redshift. There's so many reasons for it. Could be, right? I don't know. But once you observe that, oh yeah, they redshifted in quantized steps. Like, okay, excuse me. Whatever you tell me, you're wrong. We obviously don't know.
So you're saying it's like a tango, like a quantized steps?
Yeah, it's like going up steps, man. Like power level. And that was his whole thing about intrinsic redshift. That this is actually intrinsic to the star, because he brought up many explanations. But it's because of what he observed, and he wrote a book on it in the 60s.
What do you make of this blood moon stuff? How come that doesn't? How come that's all red? That?
No idea, bro. No idea.
Yeah, who's snorkeling?
I'm like really trying not to make louder noises. I dropped a bunch of shit and I caught it, and I'm just, like I can't get to my mouse to.
In the Bahamas snorkeling or something, dude?
It was like a heavy shoebox. Like I couldn't hold on to. I guess rubbing up on the microphone, possible. I'm not sure, man. I wasn't. I have the videos.
Imagine being on Discord while like snorkeling or scuba diving, but being able to do it underwater though. That'd be cool.
That's definitely doable.
Did I hear that relativist try to invoke a field like 5 minutes ago?
Yeah, I think he wanted to be part of the conversation just a little bit longer.
Come on, guys. Come on,
I want
Elijah.
to
Come
chime
on.
in, but
Who was that?
The non-medium
me?
medium.
What?
Isn't that what they believe in?
Yeah, who was that?
I don't know who said that. I just heard some dude say something about, well, you could call
An
it a field, and
alchemist.
it's like, you know. Oh, you're talking to me, Broskies.
You're kind of low, dude. I mean, what were you saying?
Oh, about invoking a field, you know, like it's funny, like they say anything but a field, but in quantum mechanics, their description of, you know, the mechanism behind it is that it's something that has a value at every point in space. And so, I mean, that's a pretty adequate description of a background medium, if you ask me. So,
Yeah, that's what
yeah,
I said actually. That's what I meant
yeah,
also when you say it's a medium, it's like if it's like a medium that is not something that something else can be in. It's just everything that there is, right? It's like even when there is water, it's in the medium. It's that medium, and that's what we call like kind of like what space-time is, which is you could call it a medium if you want to, but I think it's the same thing. The
I
way
have
you
a
explain
strong
it, at
problem
least.
with space plus time.
Two
Well,
nouns
I
become
don't know what the
one.
difference is, to be honest.
Time is a concept. Space is a measurable thing. Yeah, it's also a concept what we can measure it. Yeah, not only based on a concept in a physical real world. Yeah. Measure in a sense of length measurement. Okay, time is a concept of observation. That's the difference. To combine space XYZ plus time is an error in my world.
Of course it is. How many hours are in a square meter?
How did they stitch time and space together?
Yeah, how many hours in a square meter of time of space?
That's one Minecraft block if you're paying attention at home.
he found it. The missing link.
Yeah, you didn't know Minecraft was metric? You didn't know that? Okay. You could do all your solar tests in Minecraft. You got precision flat plane, right? Come on, guys.
Yeah, but to me, that really is the crux of the issue when you get right into you can just go right into the quantum, because they're having to use language that is in every way defining a background medium, an ever-present background medium. It's completely inescapable, even within their own language. There's just this, the ether doesn't exist crowd, you know, and that's just not being objective, because the objective science tells you that it is there. You have to invoke paradox otherwise. And then there's these people that are like, they call people, oh, the ether cult. You know, I even asked somebody before, I won't mention any names, but I was like, so you're a relativist? And they're like, no. And it's like, well, how can you go around calling people names when you don't even have a position? Mighty convenient.
What's a relativist?
Probably an Einsteiner.
Somebody who
Another
invoked
name.
paradox.
Okay. What's the
Someone
paradox?
who didn't read sufficient literature.
What's the
People who
paradox?
thinks
Which one
like
do you want?
tape measures shrink.
What?
Yeah, length contraction and time dilation.
Yeah, what's the
Faraday's
contradiction?
paradox.
Yeah, what's the?
If yes, then no. That's their motto.
The inability to unify the scales. In one. In general relativity. Gravity is an emergent property from the bending and warping of space-time, but in special relativity, it's an actual force. Things like that.
I've heard that
But special relativity is doesn't include, right? It's kind of superseded by special relativity, right? General relativity. So those two don't have to, they don't combine. It's like an addition, right?
Well, to come up with quantum relativity, you would be combining like quantum and Newtonian, I think, right?
Nobody has combined them.
in a seamless way, like you said.
Yeah, but nobody has combined them, so that's like what they're working
Listen,
on, I guess.
Listen, that information was delivered to you from like the end of a cartoon show where they say something smart.
Okay.
He just said something that supersedes is an addition.
Yeah, it's like an addition to it because special relativity doesn't explain everything we observe. What?
Yeah, but that's an aberration. How can you take away and add at the same time?
No, I'm saying it's not. If you only have special relativity, you would ignore a part of it, which is important.
Yeah, so you're taking away, but you're saying that you're also adding at the same time.
No, you're adding.
But you're superseding.
Like general relativity isn't like adding an extra part.
The if yes then no crowd. You believe things that can't agree with each other.
What can't agree with each other?
Base principles, man.
Does nature
you have to
like
be more precise? You have to be more specific. Just the principle doesn't explain anything for me.
Oh, it's like a duet where you talk at the same time.
Sorry.
That's musical.
No, what does just the principle? What does that mean? You have to be more specific.
No.
I've been plenty specific. You're talking about adding and taking away at the same time, as if that can make sense.
No, only adding.
Well, then pick a lane. You can't have both.
Adding. Can I say adding one more time? Adding.
Right, but then that disagrees with what you said earlier, so pick one.
What did I say earlier?
You said that it supersedes. The guy was talking about both of them. You said, no, it supersedes. And you said it's adding. Well, it can't supersede.
Yeah, because general relativity is correct. Special relativity is not correct.
Wait, now you're contradicting your earlier position. What?
It's not general relativity. We don't say Einstein's theory of gravity is special relativity plus general relativity. We don't say that. General relativity is the part that he solved, he theorized with special relativity, plus the addition of like dilation due to like gravity and all this other stuff.
But didn't they have to add turbo relativity for that?
Yes, they had to add turbo stuff. Yeah.
Wait, the first one gave us black holes. All right, the general relativity. What did special relativity give us?
It gives you like the effect of movement,
windows.
Right? How like you have length contraction, all that kind of stuff.
Special relativity
proven by the observation in whatever 1919 or whatever it was. Arthur Eddington.
I'm not sure. Like, I think it's like a long history of science building up gradually.
Hey, just
you're good.
I just
I'll
want to
let you
confirm Arthur Eddington is one person, not like a Michelson-Morley concept.
I'm not sure. Actually, there's two
Okay,
people observing on two different continents
wanna
at the
know.
same time.
I always assume Arthur.
Was reported to be cloudy, but anyways, we'll get back to that. (1918, 1919).
I don't think it was like one. You can say, oh, this discovery, therefore it's like building upon each other.
It would be like claiming Eratosthenes
Kepler,
fucking measured the Earth's
Kepler, Newtonian stuff. I mean, there are some good podcasts, I think, on this subject. Like people explaining like the history of physics, basically, and cosmology. And they all build upon each other. There is no like there is no like restart exactly. Like there's like, oh, this was completely wrong. We have to do it over.
Right. So now we know that when Newton observed the apple fall from the tree, it was due to the interaction of the apple and the quantum field that accelerated towards the ground. Yeah.
Now we know more depth to it, right? But like what he understood was that there was something with the Earth that made it drop.
Yeah, because there's already quantum torque, and then this thing's starting to move through space, so it produces a reverse torque. Now you have a force and it accelerates downward.
Right. Is quantum torque just naturally happening?
What's reverse torque?
Oh, that's the interaction with the quantum torque.
I'm not like, I don't have like a fucking master's degree in physics, but you use
you're
terms
good.
I've never heard
There's
before.
fluctuations.
Is quantum torque like a primary tension that everything has naturally, or is it caused by the falling of the atom?
This is the quantum fluctuations, right? They fluctuate, so they create torque between the dipoles, the rotating dipoles. Okay, the rotating dipoles, because they rotate, they have a torque. Okay, so whenever you have something that's moving, you are interacting with that always fluctuating medium, dancing back and forth, torquing. Yeah, that's what they're saying, the quantum guys, and I like it. Because that's what Maxwell. That's what Maxwell
always follows torque.
Yeah, but like Maxwell,
right,
with his quantized ether, right? Which again, the ether like it exists in like discrete steps, like a magnetic field or these flux lines that are emanating around a magnet or from the magnet, or whatever. They exist in the discrete steps. There's no half magnetic line that exists in space, and they're absolute. Like you can have one here and nothing here, and one here and nothing here, and so on. Where it's discrete.
With magnets, magnetic fields.
Quaternion arithmetic. Is that what you're speaking of?
That's one guy, right? James Clerk Maxwell.
That's magnetic flux. Yeah, just one guy. Yeah, James Clerk Maxwell.
Quaternion arithmetic. Most people aren't even aware of it.
Sounds like a law firm.
I mean, Faraday's laws certainly they are not quantum, as far as I know. So, what kind of laws are you talking about to explain the magnetic fields?
I was talking about just discrete steps, something that exists that in
what law or what principle? Explain.
That's in magnetism. Go to Oliver Heavyside. He wrote the electromagnetic fucking curriculum, volume 1 and 2. He's the only guy that wrote it, really. So you'll see that like the magnetic field, it exists in real steps. There's no half step in space. There's no half magnetic line. It's always one line or no line. There's no half line. There's no such thing. Same thing with the electrical force. Like it exists here, but not here, and here, and not here, and they're discrete. That's what discrete means. There's no
but
point
Faraday's
something.
Laws are not.
They're absolute.
What kind of laws are dictating this? Because I had magnetism at university, so we did calculating magnetic fields from shifting like electrical fields, and we use I guess what's the it's Faraday's laws. I guess I'm not sure what the name
Was
of
it
them.
Faraday's? Or was it
Yes.
Steinmetz?
No, let me see.
Who came up with the mathematics?
I think it was several people, but primarily I think it was Faraday.
But James Clerk Maxwell sounds much more like a law firm.
Gaussian
most
law,
likely
Gauss law for magnetism,
Gauss. Okay.
or Faraday's law for magnetism, but all of them are non-discrete. They are continuous.
You're not talking about what he's talking about. You're not listening.
Yeah. No, I am listening. I'm just wondering what kind of law explains it as discrete steps.
Rather than listening to what he said.
Okay,
I'm asking
I know what he's looking for.
I am asking questions. Which kind of laws?
That would be 100% in Maxwell's paper, where he's talking about psi, like, with the Greek symbols, psi and phi, one for magnetic flux and one for electrical flux, or field, or whatever. So it's absolutely Maxwell. 100% in Maxwell's paper. Right? If you want,
nomenclature
just
typically B for magnetism, but yeah.
Magnetic fields, yeah, the BH fucking diagrams and shit like that. But you go to Oliver Heavyside for
simplified Maxwell's equations.
Heavyside first, and he's still the father of the curriculum of electromagnetism. Like most likely the equations he used from Oliver's.
Well,
I have maybe the book was written by him. I have the book still. I haven't thrown any of it away. It might be that I have it.
It's just printed in like 1900s.
Oh, okay. It's not that old, so I guess it's not that one.
The sticking point seems to
conversion
be
from quaternion arithmetic to vector calculus was allegedly because electrical engineers would not be able to recognize or calculate quaternion arithmetic. And I think that's bullshit.
What's it called again? What did you call it?
Quaternion arithmetic. Quaternion.
Was that like is that like a 4-phase power or something?
It's four-dimensional arithmetic that gives you way more
Quaternion
arithmetic.
Yeah, Syrus,
This
you're
is
gonna have to
James Clerk
repeat the
Maxwell's
discrete part again.
equations. Once you learn to read it, it is simple.
Here, bro.
It's kind of like complex numbers, but with additional vectors. I just reading from the Wikipedia.
This is a diagram from Maxwell's original paper. This is what he theorized the ether would look like. That's in his OG paper.
Wow, that's exactly what seeing the inside of my eyes looks crazy.
The bees are etheric. Who would have thunk it?
Like when you can like see your own eye, see yourself. That's what it looks like.
Yeah, but Cyrus, I think the part you'll talk about discrete seems to just not land very well for some people.
Like, see these hexagons? You can't have a half hexagon in reality. So, you know what I mean? That's what it is. That's all that means.
Yeah, it's called two triangles.
Not quite.
Maybe I got the numbers wrong, but you know, like everything is triangles.
Yeah, until it's spherical. Oh, but wait, there is no sphere.
This is the Maxwell vortex model. But you see, hold on, I'm trying to get you another one where these hexagons are simplified into just circles, like the dipoles, like the quantum dipoles of the modern theory stuff, and the rotation of the dipoles. Back to the quantum torque that I was talking about.
The gaseous nature of the ether, I think it offends people.
It's okay. Yeah, I still like Maxwell.
You gotta light a match or something.
You should find the quaternion arithmetic being used in graphics now and for a while, so people that are aware of it, programming the graphics,
Is that an actual
that
diagram of
is
a nothing
something.
burger?
Yeah. Sorry, I
Could
just wanted
be
to say. I just wanted to
Max
say
Planck.
that. Yeah. Sorry.
Is that an actual
that
diagram of
is
a nothing
something.
burger?
Yeah. Sorry, I just
Could
wanted
be
to say. I just wanted to
Max
say that.
Planck.
Yeah. Sorry, I just wanted to say about the quaternion. I was actually thinking about, like, I'm not trying to like brag or anything, but to me, complex number seemed kind of arbitrarily used as a mathematical tool, which didn't in reality had anything to do with like root of -1, which is the complex number. Sure, you can do arithmetics with it. That's like, I guess that's where its power is. But what I was thinking about, one of the application was when you're gonna, if you have an electrical circuit and you have the capacity and you have the fucking
Inductance.
inductance. Thank you. Yeah, you have the inductance and you have the capacitor. Henry and I don't remember. But anyway, when you
Farads and
when you
Henrys.
yes, when you add them together to calculate it, you use complex numbers. So you say Drossel is multiplied by I. So it's multiplied by 1. No, sorry, not multiplied by I, but multiplied by just multiplication. And then you have capacity multiplied by I. So it's square root over 1. And when you add these together, they can cancel each other out. So you remove any capacity if you have several, if you add them together. And you get components. So you get the I component, which is the capacity. And you have the non-I component, which is the Drossel. So, and to me, it seemed kind of arbitrary that they used complex number, because I was thinking, well, can't they just add? They could just add just add an algebraic number to it. They don't have to use I. It doesn't matter what they use. It's just arbitrarily. What you could say? It's a good tool to calculate it, sure, but it's just a mathematical tool. It has nothing to do with square root over -1. In reality, it has to do with them being separated into different dimensions in the math, like a matrix. And I mean, why can't you have more dimensions? You could just add any dimension to it, and they say these need to be treated separately. It's like a different number system. I was thinking that at school, and that to me seems like it's quaternion. I can't even say it. Quaternion. Holy shit, I can't even say it. But to me, that seems like that's what it is. It's basically that system. Because it's like just like a mathematical tool. You can just apply it. And I was thinking, when you're saying graphic, I mean, you can treat different dimensions as different, or you can add it as like, I know you have like a vector, but you also need to have a number for depth and stuff like that. You need to know the depth. How deep is it? And maybe that's when they can use it. I don't know, but that need to be treated differently. And then you can just use quaternion or complex number. It doesn't matter. I have the I have the Introduction to Circuit Analysis book here right with me actually right now. I'm going to open it and look at it. It's I learned it at school. I haven't like touched it in fucking 100 years.
So if
you want to read the real material, sorry, Oliver Heavyside theory, electromagnetic theory. Download both volume 1 and 2 from archive.org.
Wait, what's
the guy?
What's his name? I tried to search for it. I couldn't find him. Oliver
Heavyside. Yeah, the spelling of Heavyside. Yeah, Oliver. Yeah.
Yeah, coincidentally, or non-coincidentally, not that heavy. Maybe even underweight. Before we were talking about redshift and stuff like that, in discrete steps and that, and then you were talking about also magnetism, discrete steps. Possibility these two things share like a common ancestor, like a duck, or that they're basically like they're within the same physics. I'm sorry, I'm joking around with the duck thing. I don't know what I'm talking about. But do you fashion that possibly redshift could be dwelling within an electromagnetic phenomena, or redshift, blue shift?
I mean, yeah, of course, according to the speed of light, yeah. To the speed of light, again, back to Maxwell and electricity, his greatest discovery, if you take the total electrification in a circuit and divide it by total magnetization, you always get 1 over the speed of light squared. So anyways, Maxwell, with the speed of light equation depends on the properties of free space. So if those properties change, the speed of light would change. And of course, yes, that could cause your redshift or blue shift. If there's different properties out there in space that the light is traveling through.
But that
electromagnetic properties, yeah.
But that might not present itself in discrete steps. Like the shrinking of a given amount of space, like does not have to fit a quanta of red. You know what I'm saying? Like so.
No. Yeah, that's not how the quasars, like some of the quasars, and shifting in discrete steps. Yeah, that because they're saying it's expanding, right? So it should be a gradual shift, but it's not. So that just kind of shreds the normal cosmological model of gradual expansion from the Big Bang.
Syrus. Listen to this. The stationary effect was an effect. Wait, I don't know why. The stationary wave was an effect unknown in electrical science. It was unknown because electricity is a bipolar manifestation. Ether, being a natural radiant energy, has more in common with gases. That's the problem that many of them have, right? They use the same word when trying to talk about different things or different manifestations.
Yeah, man, I do not know. I'm still trying to figure things out. But I definitely went quantum field theory for sure. These guys like put the numbers on the ether for me. They're saying the same exact thing, right? So the electrical conditions of space determine the speed of light. It's like, okay, cool, sweet. For me, like, how do you change those? We don't know yet. But the sun does change it whenever we get solar flares and stuff. So that's why Maxwell was a big deal, man. He is okay. So he's given credit for being the first guy. That's why Maxwell was a big deal, man.
Was he the one who proposed the magnetic waves?
He is okay. So he's given credit for being the first guy to put the Leibniz and Newton, right? Leibniz-Newton calculus to the electromagnetic theory stuff, electricity. So he's the first guy to apply calculus to it, and he got great discoveries out of it. So that's what he did, and he was trying to invent radio. He did not. Tesla did, but that's what he was actually trying to do. So he wrote his 20-page paper, just one equation for that. He's like, all right, series of equations, just 20 pages long. He's like, all right, bro.
And then radio was swiftly obfuscated into what it is now.
Well, the idea is you cannot transmit electricity through space without a medium being there. Maxwell put the numbers on it. If you go to like Maxwell's ether, you know, they'll have a Wikipedia page on it for sure, saying that he was wrong and whatnot. But yeah, whatever.
I think one of the issues that Marconi had is because he didn't understand stuff and he needed to avoid the patents, right? He did crazy losses in his transfers, forcing it to be something other than what was intended. You would think just from a monetary point of view, you'd have the humility to go, all right, this is a waste of resources.
You don't like Marconi? I don't like him as well.
No, I know. I'd respect him more if he played the games better, but he played it to his own detriment. So
He got kicked out later.
I'm not surprised. But
some people got thrown out, so to speak. You familiar
With
with
the
the
war.
Royal Society and what's accepted and who accepts what as being legitimate and empirically true, etc.? Well, people like Nathaniel Stubblefield, John Keeley, and others.
Oh wow, you know about Stubblefield and his Earth batteries? Amazing, amazing, and his telephony.
Well,
Earth-based.
we're in the middle of the high, the solar maximum for the rest of the year. So yeah, I've been keeping an eye out for anything resembling Carrington event or anything like that. Once every 11 years.
Yeah, dude, if you ever figure out how to build one of them Stubblefield batteries, just send me a DM.
Okay.
If you're getting like serious power out of it, you know what I mean? Like the stuff that he was getting out of it. Because like most people don't know about him. If you ask like, hey, who invented the telephone? Well, you get the wrong answer every time.
Well, so many people had credited inventing at the same time. Like when you speak of Marconi, well, Tesla didn't mind it. He didn't mind it at all. That's why he's
What if there's another guy that preceded all these guys, and Nathan?
There were.
Stubblefield.
There were.
Nathan followed in his footsteps.
who was the German that Tesla like went on from? I think it was German.
John Keeley was one of them.
Because I have the book.
He
You
worked
talk about the German.
He worked with Stubblefield as well. They jointly filed a patent in 1898 or 99 together.
There was someone who was older than, like, from the generation prior to Tesla, who it's cited in that Vasalatov's book, but I can't seem to search on this.
The guy that he went all the way to Germany to correct would be Heinrich Hertz, Mr. Hertz.
No, not that one.
Heinrich. Okay.
I know about that.
Which,
but no,
what German guy? That he likes?
Maybe no, something that he was like credited and it was put into, like, he and a bunch of Tesla's contemporaries looked back on and built upon some of the stuff he did, but I just can't remember the name. I'd have to go and read it all, but it won't be good for the conversation.
Good.
Well, depend.
Do you know about what's his name? I think his first name is Antonio. I think it's Antonio. Don't quote me on the first name, but last name is Mucci. Antonio Mucci. He's the father of telephony, but it was Earth-based. It was ground-based telephony. And then Mr. Stubblefield, again, it was ground-based. And there's evidence all over. People said it's flawless, super clear, and all that. It's interesting stuff.
It's not just data transfer. It's also energy. And that goes with every bit of it. It's data and energy.
Right.
Because what Tesla said about, I think he went on from something that Thomson did. But what I think the way Tesla put it is instantaneous reproduction of basically anything at this point. But in order for that to be true, it agrees with what the other gentleman just said, right? It would be information, the voice, and the energy, because it's reproducing, to be reproducing the vocal output.
Oh yeah.
That's just
We'll
as
see.
an example.
Yeah.
Because we don't have because sorry, just to clarify, the reason that that's important and the reason it's different is because we don't have that now. We have a facsimile. Like you're listening to a facsimile of my voice. You're not actually listening to a one-for-one reproduction of the way I'm delivering it and the cadence, etc. It's as close as, but what Tesla was talking about was tuned circuits. It's like, here's my voice, and then I'm just sending my voice to you over there.
Basically, teleportation.
Yeah. But it's a hard one to swallow for people. But if you had enough mental flexibility, you could just use twins as an example. There's clearly a link there. They're clearly a really good representation of tuned circuits. And the things happen to them from across the world, and they feel it. So it shouldn't be that hard. Yeah, it shouldn't be that hard. But for some people, it really is.
Well, it depends. Like, if as you as an individual, how many fingerprints and scars you had placed upon you since you were a young child? Everyone's different too, as far as their gifts, knacks, talents. That's why we're all different. We strong here, weak there. You're strong there, and I'm weak there. You see what I'm saying? We need to communicate. This is awesome. I hope that everyone is interested in this is actually learning and looking into it.
Yeah, I think when Syrus, do you know when Thomson lived? What range? JJ.
Oh, JJ, bro, same time. I think his paper, his Nobel Prize paper. Goodness, forgot what year that was.
Did he work with Heavyside, or were they just contemporaries? Like, did they work directly?
No, I think Heavyside should be before. A little bit before them.
Okay.
Heavyside is the guy. Heavyside, okay, the Telegraph. You should know this because you're across the pond. This is where Heavyside, the physicists versus the Heavyside. All right. So when they set up the transatlantic telegraph line, they of course they sent the signal and it did not go through after several tries of pulling that cable all the way across. But anyways, once they got it, the signal did not go through. The physicists theorized it was due to diffusion in the wire. So we just need to amplify the signal. I mean, so they just added more power. It did not help. Oliver Heavyside, he was like, no, it's because you're sending an electromagnetic signal and the magnetism is getting eaten up by the wire faster than the insulation is eating up the electric portion of the signal. And he's like, just wrap the wire in magnetic tape. And they wrapped the wire in magnetic tape and the signal came out perfectly on the other side. So they didn't like that because that went against the mainstream theory of the time. The physicists said, nope, it's due to thermal, like something exactly similar to thermal diffusion. He said it's due to diffusion. Oliver was like, absolutely not. There's no way. The fusion has got nothing to do with this. This is an electromagnetic signal. And he was correct. So, yeah, Mr. Oliver. He gets credit for that, but they don't give him credit for that. But he does. Right? You got to read the right newspapers. That's what he did. Then he wrote, of course, he wrote the curriculum on the electromagnetic theory. So he's an older fellow.
The amount of amperage Stubblefield was able to draw from the ground was extremely impressive.
Well, you know the thing about Stubblefield, right? I know I'm calling it a battery. He never called it a battery. He said it's a terminal. He never claimed it's a battery. 'Cause if you treat it as a battery, it makes no sense. Like it should not. It will give you very low volts, man, if you think it's a battery. But he said it's a terminal.
Who
That's
drew
like-
amperage from the ground?
Nathaniel Stubblefield.
Samuel Stubblefield. I got to look at that.
Yeah, Nathan Stubblefield from Indiana, if I'm not mistaken. Kentucky. My bad.
How dare you?
How dare I, Brad? But for left lane, check this out, because his claims are like out of this world sort of stuff. He was able to pull out light out of the ground and stuff like that, weird stuff. Anyways, post his death, some factories were operational. They dug up these so-called Earth batteries, the Stubblefield batteries, in sets of like dozens and half dozens, and they did power factories with them, as he claimed. When we like doing some excavations around old factories, oh buddy, they did find them. And we got photographs of this shit. So it's like, okay, there's something here. Yes, commercial.
When he calls it a terminal, does he use it in the same way that terminal would be used for a network, like on the
Yes.
network, like internet type?
Yeah,
it's a node. Is what I like to call it.
Node, exactly. Power node.
He tapped into the
Get
web.
more power.
You know.
Add more nodes.
Wasn't this what Tesla was doing, right? He realized that, okay, the thing is there, but when you excite it to these different parameters, then it manifests according to what, the code that you've put into the web.
Well, that's why Jared Vassilatos, he starts off with Antonio Meucci, he goes to Stubblefield, and then he goes to Tesla, because Tesla is the guy with his telluric currents, sending electricity through the earth and getting it amplified 20-1 was the ratio, if I'm not mistaken. This is significant. So this guy's the pinnacle. This is why Tesla, we see what he built, because he kind of refined all of that, right? But it was all from the earth, right? It was all same exact line. It's like there is power streams running beneath you, electricity, rivers of electricity, like Thomas Henry Murray called it. And you just need to tap into it. But the nature of the electricity is non-alternating or direct. That's why we were stupid. We can't get it.
The ground and the sky. Elevation. Tesla's the Warden Cliff. Most of his work was in the ground. If you're familiar, if you've seen photographs of, if you're familiar with Victor Schauberger's work, you'll recognize the geometry.
The dendritic structure.
Yep.
Or dendritic, however they call it.
Yep.
Yes, of course. Schauberger, of course, man. He's another anomaly. Like, all right, buddy. His heating device that they found in his house, same exact thing with Stubblefield. After his death, they go in his place, bro. There's no heater on, and it's perfectly warm. It's like, all right, this is interesting. Like, how did he heat his place, bro? Unknown, but he definitely heated it somehow. I don't know, man. Schauberger, there's this copper disc device that supposedly, when you spin, you can just get heat straight up. It's like, okay, Schauberger.
And they all did one thing. They observed nature and copied it, basically.
Yeah, I think that's the difference between what Tesla did and what they did, is that Tesla was understanding it.
They're all the same. Like he said, harness the wheel work of nature.
Yeah, I think there's a slight difference in that. With the example, first of all, he starts by trying to confirm what Hertz did, and then realize, oh no, I now have to tell him what the reality is. But that opened up a whole new world and a whole new perspective for him. Whether that narrative is true or not, I don't really know, but that's how it's told, right? And then
We did.
And then he
sure.
proceeds to get an effect, and he's like, "Hold on, what's happening here?" And he's reading the literature. He goes looks for it. He's got a few different examples that he finds, or a couple of examples. But these guys were having these effects happen by accident, happenstance of the design of a building, or just the way that certain things were lining up, because they didn't know that they would have to control for the variables of the water and the copper in the house, right? But he took that and goes, well, now I know, now I can understand this, and now I can control it. That's where I see it as the distinction, because they were kind of just lining up. Like if you with modern vehicles, if you copy an animal that has a similar function, cool, but why? Like get deeper than that. He got deeper than that and then manipulated it to his own ends. And just to finish off, because I think it's fun. He confirmed what Mendeleev had already proposed with the lighter than hydrogen, or however he phrased it, which is
electrogen. I got the
yeah, man.
free hydrogen atoms.
Yeah, I don't know if the name is that relevant, but yeah, I think that's might be what he called it. But
I like
because that's
electrogen.
what's funny, right? Because then you read the way. Yeah, well, that's what I think Tesla and Vasilotto's book puts it in perspective what Tesla was doing, and I think Tesla must have cited it in one of his journals. But with that, because the way he concludes one of his positions on it is, I don't know what electricity is, but it behaves as a gas under pressure or a fluid under pressure. Same difference.
That's what Tesla called radiant energy. The heating that you guys say, apparently he had an apparatus in the basement, and that's what heated it. He called it radiant energy. It was like, think of it as a fog. Think of it as a fog of like spreading out over the apparatus. That's what and Terry Kalakos did a thing on it. He did a thesis on it. He explains all about it.
And you probably lost a lot of people when you brought up telluric currents, and most people aren't aware of telluric currents, not to mention how they can affect our observation of astronomical bodies through telescopes, etc.
I checked the Stubblefield guy, and he had what they called an unsubstantiated claim of drawing energy out of the Earth, or amperage from the Earth. It said it wasn't substantiated. I couldn't find anything on it.
Yeah, that's what they claim. But then they got photographs of pulling these. They were pulling these things out of the ground. So it's kind
That's
of
what I'm saying. They got thrown out.
Leaves you wondering.
John Keeley is another one that got dismissed, basically.
Yeah, Whirl Keeley. Yeah, know about him too.
John Keeley.
Yeah, John Keeley with his spheres. Yeah, with his I know the guy.
That stuff is simple enough. You can do it in your backyard, though. If you go check his setups and what he claimed there, you can do that yourself.
If you read a little bit more into his claims, and you'll understand that he's not talking about conventional electricity. That's why Elijah brought up Tesla.
Yeah, you can make an earth battery, though, with like dissimilar metals, and stick them in the ground, and you can measure.
Garbage stones.
Yeah, it's just not enough power, or what we call, we need amperage. Voltage and amperage makes power, and that's the problem. We don't have the power there. Lack of amperage, no flow current.
So let's call that kind of electricity chemically generated electricity from a chemical reaction, right? A conventional battery, right? We're looking for a direct current at the end of the day between the chemical reactions, between the dissimilar metals and the medium you put in between them. So what Nathan was talking about is not a battery. It's dry. That's what I'm saying. It's not conventional. What these guys are talking about. If you go direct DC, chemical reaction, you're going to get very little voltage and amperage out of it. I've seen plenty of videos on it.
This is where Vasilata's book is good to kind of bounce off, because people are unaware that when you use the same words in different contexts, you have a different application come out or a different result. So because I heard about his book first through Lindemann, right? Lindeman's lecture, and what he said is basically, if you don't realize that Tesla is having different definitions for these commonly used words, especially now that it's 150 years later or however much, right? You're gonna completely misinterpret everything that he's recorded down, because he doesn't define it the same way. And then Lindemann's book is helpful for that, because
I think was it Lindman or yeah, I think it was Lindman during one of his lectures, or he simplified it. Impulse DC. He's like, is your way into all? Then he's correct. All these guys is why when you go with your simple meter, well, these guys are talking essentially about impulses, electrical impulses that come in series of trains from like in a train format, just like your nervous system, right? It works on electrical impulses. It's neither DC or AC, but you could recreate it by having storage banks like as a capacitor and instantaneously discharging it. And in the so-called instantaneous discharge, the rise to these effects happens. According to Mr. Tesla.
That's what they had to deal with, because sorry, let me step back a bit. The impulse thing is dangerous if not managed.
Killed people.
Because with his dynamos, people were being vaporized because they took.
It wasn't a joke, dude. People died.
Wasn't it because they took his stuff and they didn't listen to everything he said? They just took half of his work or something. Because then
that's why Steinmetz comes in.
Oh no,
Steinmetz. They get Steinmetz from Germany, General Electric, to run around Tesla specs because all their motors were burning up and shit. And he's the one that discovered, like, in the transformers, instead they were just using solid iron core, and he's the guy that put the math behind it. He's like, no, you need to use laminated silicon steel because that would guide the magnetic structure, right, the magnetic field, rather than absorbing it, so you don't get the heating and burning up effect. That's why you look at all the transformers, they're all laminated. Your motors made out of laminations. Due to that, Mr. Steinmetz.
By that point in the narrative, had Tesla already moved on?
Way moved on. His stuff was laminated from the get-go. They just didn't know. It's like, all right, cool. Yeah, so he knew that. Tesla had no math behind it, so it was hard to... So it's new stuff. He had it figured out in his head. It just works. Didn't leave us with equations. And Steinmetz is the guy that now broke down what is actually happening here. Because you have real phenomena. Why are these motors burning up? I see. Because the steel core, the iron core, is absorbing the magnetic flux rather than guiding it, like in a transformer or so. So
I guess,
and then you just laminate it.
I guess the problem of specialism was already there at that time as well, because Tesla wasn't a specialist. Tesla, I know that's maybe going to be misinterpreted, but he was able to understand all the elements of what he was doing. Whereas some of these people, they were just hyper focused. They were just technicians. But you can't get a technician being responsible for the whole project. It's not wise. Because his material understanding was as equal to his magnetic and electrical understanding. Because they go hand in hand.
Yeah, and it leads up into shunning the magnetism out of this world, essentially, out of your apparatus. Get rid of that stuff. It's parasitic. But that's later. And you get into magnetic hysteresis if you want to read some complex math from Steinmetz. Magnetic hysteresis. And you want no hysteresis in your system. Hysteresis is the enemy, turns out to be. So that's why you discharge the capacitors as fast as you can. Right? and then you get these anomalies that Tesla got, and then he just did it repeatedly.
You guys are talking my language right now in regards to this subject. So when it comes to the laminated cores and also hysteresis, however you pronounce it, I always mispronounce it, but and there's also eddy currents, and that's why they started laminating the cores for different types of materials, is to reduce or highly reduce the amount of eddy current losses in the electrical signals.
Yes, sir. Mr. Steinmetz was the guy that put all the math behind it, all of it. So nobody had it figured out at that point. Tesla did with Westinghouse.
One of my favorite things about what Tesla did is to actually be able to understand why you can have lossless transmission or over unity. Because it's not just, hey, look, we built this thing and it's lossless or it's over unity. It's why it is like that, and the why is because of the medium, right? So when you do the manifestation with what you were talking about, in line with the medium, then the medium feeds back into the power transmission. It's better with pictures.
I mean,
that's the best I can do with words, right?
We have to get this out of the way quickly with electricity, right? Because you're dealing with massless objects that has no place in physics. Physics, you need a unit of mass, distance in meters and time in seconds, right? And so mass in kilograms. Now you're dealing with something that's massless. In a vacuum chamber, when you pull the hardest vacuum you can pull, there's no gaseous anything, pretty much just a couple of molecules. You can still transmit electrical signals right through it, and it still has resistance of 377 ohm. So due to that, we move on forward. That there's absolutely a medium there that's not air, and that's what we're talking about to transmit these signals, and we just move on. And there's two of them, like the guy that said the quaternion mathematics or whatever it was. He's right, because electricity has 4 poles, +1, -1, and plus J and minus J. Back to the square root of -1, we're going to use that for the electrical field. And the magnetic field, we're going to use +1, -1. And now we can move forward and engineer stuff.
Yep. Now we can talk about overtones and harmonics.
Dude, Tesla, according to the legend, he tuned his circuits to the 4th harmonic. He didn't have an oscilloscope, huh? You tell me how he did that.
You don't need it.
I've got no idea.
A musician's ear.
Yikes, buddy. Yeah, that's Keeley. You're going to get into Keeley with the harmonics for sure.
Harmonics is electrical noise, and like harmony, if you're going to say it like that, some people start to get a little like, oh, what the hell is being discussed at this point? Well, harmonics is only associated with alternating current, and that is, you can actually look at it with an oscilloscope and see how it's actually functioning. And what it does is it creates an uneven sine wave across different types of these 3rd, 5th, and 7th harmonics. And it's really weird how it works, but the way it can be limited, the way that it's usually associated is with things like transformers, ballasts, motors, things like that. But there's these things called style K transformers, where all they did is just figure out how to eliminate a lot of that, and they just increase the winding size of the transformers and eliminates a lot of it. But
due to the geometry.
Yeah, exactly. Yeah, it's graphable, yeah.
Yeah.
But yeah, when you get into the complicated, nerdy stuff about it, it is complicated. But I mean, I could show it to you guys. I've done it before.
No, I mean it's the geometry, the physical geometry of the coil. Like, because it's a musical instrument. Like, let's say if you're operating at 200 hertz, or let's say 100 hertz. Right, the 2nd harmonic, 200, 3rd, 300, and all that. Those, you don't want those, obviously, if you want a clean sine wave out of it. But they're because it's a musical instrument, those will automatically resonate too, right? The 3rds, if all of that. So you have to filter them out, like capacitors, inductors.
That's how we have 3-phase power, is utilizing the harmonics.
Yes, well, here's something interesting, is that a lot of there's this one PhD electrical engineer, and she was, which is a very rare thing nowadays, and she was saying that we need to move outside of the 3-phase power that we're currently using in most countries, aside from just like solar panels and battery banks and blah 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 whatever. So she was like, well, we need to go into 6-phase power, or even 9-phase power. It's like, whoa. I mean, if that was the case, the math makes sense, but it would have to redesign, a lot of the electrical industry. So, but when you start thinking about it, it's like, yeah, why do we even use 3-phase? Why is it not 4-phase or 5-phase?
Exactly. And then what we can acquire when we have that, plus I've got calculated up to 27 circuits. But yeah, going up to 6 would be awesome. 9 would be more awesome. But that's probably going to be in the future.
Yeah, the reason we're not
Probably
going to
won't
do
see
it anytime soon is if anyone were to do that, they would have to it'd have to be like a brand new neighborhood or a building that was just completely independent from everything else. And it would just be extraordinarily difficult to have everything on the electrical grid just transformed into 6, 7. I'm sorry, a 6. It has to be in increments of 3 because of
Yes,
vector math.
3. Exactly. That's why we're going up to 27.
Yeah. So, yeah, 27. I mean, yeah, as long as it's in increments of 3.
Correct.
Then
but
yeah,
that's as high as I could get, and actually, in my mind, see how it works. But everybody's different, I'm sure I'm missing so much, man.
Oh man, I think all that is too much, bro. Go back to Nathan Stubblefield, Antonio Meucci, and Mr. Tesla, Dr. Tesla. You need just one pole, Earth pole. That's it, apparently. But it's not DC or AC. It's in impulses. And they do have harmonics because you can also operate a transformer, which only works on alternating current. You can't operate it with a direct pulse, you charge a capacitive bank or you discharge it, so it's electrical impulses, right? Because you need a changing magnetic field to induce the magnetic field on the other set of coil. You got the primary coil and the secondary. So if the field is static, you cannot induce it. It has to alternate or move, right? So if you have a coil and it's got the magnetic fiber structure around it, let's say connected to a battery, so it's static. Once you disconnect it from the battery, as it's collapsing on itself, it will induce a current in the other set of coil that you have next to it, right? And depending on the frequency that you want to operate at, you'll determine the core and the core material and all that. Like higher frequencies, you just need air core coils, like Tesla stuff.
Yeah,
Just
and
in
from
higher
that
frequency.
form to function, the design itself is conducive to a certain frequency. It was called phenomena for a long time. A lot of things that I was taught as detrimental, like a factory defect, like cavitation, nothing but detrimental, right? Turbulence, nothing but detrimental. But then I learned, whoa, no, nature uses these things to the benefit. And then, it's like, oh, this is how Schauberger saw it. A fish effortlessly in a swift stream staying still formed a function. It was a eye opener.
Got to go the other way. Harness the cavitation of the impeller.
Oh my goodness! It's once you learn, if you have this cavitation before, like if you're trying to propagate a matter, right? Cavitation before it, and this is known. It's not, I didn't come up with it. I had to look and find it. But once I did find it, I was like, uh huh. When you got a gut feeling about it and you do research and you find that affirmation, confirmation, and hopefully you don't have the bias that's clouding your evaluation. That's why I like to bounce off a good company. That'll point me out when I'm wrong, I'm making a mistake, or misspoke.
I have a question for everyone, only because I'm an electrical nerd when it comes to this stuff. We have AC and DC, and I always talk about this, asking people if they have just kind of ping-ponging information back and forth. Do you think there's a possibility for a different type of electrical power?
Yes, that's what we've been talking about.
100%.
All right,
I'm
and
That's
what would that
exactly what we've been talking about.
There's again, can I go back to Steinmetz? I forgot which book exactly. It's impulses, something, alternating waves, and other phenomena. Open that one
Yep.
up.
That's a
It's
good
in the
one.
beginning.
Charles.
Right there. He'll show you about like, like a mechanical. So if you have a pendulum and you let it go, right? You have this oscillation, but it's also dissipating over time. So when you graph it, the sine wave, the amplitude is dissipating. Okay, and he classifies these things in electricity. What happens and how this destroyed shit back in the days because it's parasitic and the equipment isn't built to pick it up. So we had no idea. Back in the days that this stuff is happening while they're humming at 60 hertz and it's just blowing stuff up, man. Like the what was it, the New York rail incident or something like that, or like the whole entire track lifted like 3 feet in the air
Shooting
from a blast.
50 hertz. It was 50 hertz back then, bro.
50.
Yeah, 50.
Yeah.
Well,
yeah, there is some serious incidents.
If there's hertz being used, Heinrich Hertz, then that's where it basically just is a fancy word for frequency, like cycles per second. But if you're saying hertz, then it has to do with AC. If there's no hertz, then it's DC. So if you just completely eliminate that word entirely, then there has to be some other conceptual idea. And Steinmetz, yes, he was also a grandmaster chess player, by the way, and I don't understand how exactly that would still. I'll have to look into it a little further, but yeah,
practically, you'll understand. Like, let's go practically how it's done. There's only one magical device.
Telluric
Go for it.
currents. He already brought it up. Telluric currents. Check it out. It's both magnetic and not magnetic. It's
Professor Dollard has a great book on it called, I think, Telluric currents. It's just a short, like 20 pages or something.
Need to check that out.
I posted the
You bet, man.
Jerry
Breaks it down. So practically, we get into the electrical impulses, right? Where it's in the title of Steinmetz's book. Tesla is able to get all these phenomena with electrical impulses. It appears these rivers of electricity that run in the earth, they're the same exact electricity that runs in our bodies, electrical impulses. So the way he was able to do it, which is he charged a mega capacitor bank, and he started his experiments with an experiment called the exploding wire. MIT has a video on it. Believe it or not, you can do this. Large capacitor bank, thin wire, discharge the capacitor bank into this thin wire. It goes straight into vapor. It's boom, blasts, and it just goes from metal to vapor. So he put a glass shield between him and the exploding wire, and he still got hit in the face. All right, so he was like, okay, how? Anything that has mass should have been deflected by the solid glass. So anyways, he went to lead and tried out different materials, and he still got the same sensations. And then he played around with the discharge frequency. So this is where the term frequency we're absolutely going to use, because he used a rotating spark gap later on, and that was the spark gap of death, or he crippled him from the pain, and he couldn't get to the switch. Right, so this was a horrible experience. Then he refined the pulse width and the pulse. So that would be the pulse duration, and then the pulse frequency, right? And then you have you have the duration of the pulse, like in a square wave, and then the dwell time, the time in between, right? And how many of those you do in a second, and how wide every pulse is. By playing around with those two parameters, he was able to get it to a painless sensation, and these white corona. He was very clear about this, Tesla. This white corona appeared around the coils. Okay, it was white in nature, not blue, and did not harm him. All right, and he was quite familiar with. Yes, he was familiar. They were just dancing and standing all around the coil. So that would be the secondary coil. I believe maybe both the primary and the secondary. I have to check. But the magical device here is what he called the magnetically quenched spark gap. What he wanted, the idea was to shun all the magnetism,
from coming through, because no hysteresis can be allowed to pass through this to the primary and secondary. When you have no magnetism, this is strictly operating in the electrical side from the electromagnetic wave. You're leaving the magnetism behind. It's not going on to the primary, which induced into the secondary that's connected by single wire to the tertiary, called the Tesla or extra coil. What he called it is what they call a Tesla coil. Tertiary coil is the magic, which turns out to be a virtual Earth. But that's a different story. I don't want to ramble. It's a long lecture because he's a fucking genius.
Oh, dude, you're grabbing my attention a lot, but I think a lot of people are probably getting a little lost because
I know.
Yeah,
nerding
don't
out.
get lost. I posted Jerry's book though, Andrew.
Awesome.
The history of his trajectory from analyzing Hertz's stuff to what Syrus is talking about. It's in the book.
It's in the book. Supreme book.
Because there's one thing that Syrus didn't mention after he talked about the wire, right? Because I think after realizing, these wires they keep disintegrating, because it wasn't intentional at first, right? He put them under oil, and under oil, they just kept giving off gas. That was where he started to be like, oh, this thing is gaseous in nature. And it wasn't just off gassing like it wasn't just off gassing like you would get from normal electrolysis. It would or whatever you call it. It was past the point. The volume was past the point of it making sense for it to be off gassing. Just in case that was a pushback someone might have.
Yep. Then instead of exploding the wire after that, he put a thicker wire, aka a coil now, to absorb the energy without being exploded. And then, that's the primary. Then you got the secondary. Then you got the tertiary coil. Now this is called a Tesla. This is the device that starts everything. Like, this is how you get Tesla currents at the other end. And the monopolar transmission. Because it's non-electromagnetic. It's strictly electric. It's like this guy hacked nature. This is just incredible. So the tertiary coil, right quick. So to transmit into the ground, what he did, how you need something, you need to close the circuit, or aka grounding, or something to push off of in order for you to jump. Okay, this is the earth ground, right? If I use that analogy. So in order for electricity to go between the battery terminals, you must close the circuit. Okay, put a light bulb in between to get luminance or whatever, get motion, but you must close that bound. You must create something called a boundary condition, and this is now differential equations, right? So you must create a boundary condition where the electricity is bound in a ring, and now it can do something for you. Now you're conveying it, but it turns out, according to Oliver Heavyside, you're destroying it when you do that. Okay, but anyways, Tesla with his shit, you have to leave all the magnetic part of the circuit behind, right, and operate only on the electrical side, right? So this is the magnetically quenched spark gap. For me, is like, okay, I need to replicate one of these because that's the key. That's sort of like a filter. Magnetic filter shuns the magnetism from passing beyond that gap, keeps it back by the capacitor bank.
Yeah, just to hold, you're speaking my language, but for a lot of people that are just probably getting confused, when it comes to a circuit, we have different types of circuits, but the most fundamental ones are short circuits. Closed circuits and open circuits. If you have just a voltage source, like from a battery, then you don't have a complete circuit. You have to have a return source back to its original. It has to go back to the source. Otherwise, it's an open circuit. That's how light switches work. But when it comes to why? Well, okay, then what's the purpose of a light bulb? Like a single pole switch and a light bulb. What's the point? Well, if you don't have that, and you just connect the two wires together, then it causes a short circuit, which causes a massive amount of inrush current, which will destroy the power source. So all it takes is something like a filament of a light bulb, and that's it. And all of a sudden, everything works. But yes, sorry, I'm just trying to elaborate.
This is why the background medium is so important.
Yeah, dude, you're with me on this. So in order to push into the ground, okay, what do you push off of? this is the thing. His tertiary coil, supposedly, was tuned to Earth's frequency, according to Mr. Tesla. And it was square in design, as in the width of the coil matched the height of the coil. And I forgot how many wraps it was, but it was not as many wraps. When you go on YouTube and you look at, Google Tesla coil and you see this primary, and a secondary has got 1 million windings on it. That is not, that's a spark creating machine. Tesla spark is a loss in a transmission circuit. We do not want sparks. And he clearly stated this. He put a big sphere on the end of the tertiary because it has high capacitance. It would eliminate the spark. Okay, you do not want spark. If you want spark, yeah, put a point, and then you're going to get a lot of sparks. But his secondary and tertiary, there were not many windings. His big one it's a famous picture. You can see him sitting right around the tertiary coil. Okay. It's a big coil. It's like it looks like a cage almost. He's sitting right there in the middle reading a book with electrical sparks flying. It's just a cool picture. That thing was gigantic. That's the Colorado Springs one. But yeah, so he created a virtual Earth with the tertiary in order to push off of it, right, in the circuit for, speaking circuits, to pump this electricity down to the Earth. And what he got back was 20-to-1, the ratio. And he did this at 50. He modulated the impulse at 50 kilocycles, 50,000 cycles per second. And it was an impulse that he shot down. I think duration of 1 second, and he got a standing lightning bolt for like 20 seconds or so. It was 20-to-1 on the return, if I'm not mistaken. So it got amplified. That's what he discovered. And he wrapped up the experiments, and he's like, this works. Let me go back and build boarding clip towers. It was all about pumping this electricity into the Earth, and it returns back way stronger. And you capture it then, obviously.
Yeah, and I don't understand how it's different from AC or DC because it's incorporating both, sort of like a Tesla coil, which I actually have. I built one, pain in the ass to build. I had to use like hot glue to keep the as you're wrapping it around. Yeah, it's just a pain in the ass. But either way, that would still be registered as a mixture of AC and DC. I don't see how it's a third.
That's the problem.
Yeah.
Andrew,
that's not a Tesla coil.
In the second picture I posted, though, that addresses the issue that you're having. Right? Those who attempt to analyze Tesla impulse transmitters from the radio wave perspective walk away baffled or critical. So you have to view it in terms of how he defines it. That's why it's good to read the book and read his work.
The primary, a proper Tesla coil, according to the patent, the primary is only two loops, it's 2 windings on the primary. And the primary to the secondary is tuned by mass. He tuned it by the mass. So the amount of copper is equal in the primary and the secondary. Then you have your tertiary that's tuned to Earth resonance somehow, but it's a square design coil. That's a tertiary. And it's not that many windings. You're not supposed to get sparks off of it. It's not a spark machine.
According to
yeah, bro, go ahead.
According to Terry Kalakos, the way he found that is he ran a current through a magnet, and what he saw was what came out of it was blue sparks, electrons, and also this white stream. This is what he called radiant energy. So it's like separating, it's freaked out the way Terry Kalakos explains it. It's like separating the electricity into 2 streams.
Do you mean Jerry? Sorry, bro, I don't mean to cut you off. Do you mean Jerry Vassilatos?
Yes, Jerry Vassilatos. Sorry,
Terry Kalakos. I'm like, who's Terry?
Wrong one. I don't know where I got that. Yes.
Yeah, because exactly,
you ran
bro.
it through a magnet, and this is where it got separated.
And that's the magnetically quenched spark gap that he gets into later.
Yeah,
no electrons. We want electron-free circuit.
Yeah, freaked out. And apparently the light bulb had a lot to do with it. Like Andrew said, the filament.
For Andrew, you can look up Eric Dollard. I think it was in the 80s, 87, 89. His old VHS tapes. He's doing this in a garage where he's got a light bulb. He operates it with conventional 60 hertz alternating current 120, and he's got a copper sheet hanging right next to the bulb. Okay, and he operates it. It attracts later when he operates it with the Tesla current, and it's a lot brighter too. And you can hear the thing, and it just sucks the copper sheet right to it. So action at a distance, right there, and it's very strong. It's not like, oh, this is just electrical tension. It's like, bro, this is very strong electrical tension, and the light bulb is glowing at the same time. But he just turns a switch and operates the light bulb on Tesla currents, demonstrating the different effects that this guy wrote about Tesla. And it's like, it's not, nobody talks about it. And he just demonstrated this in 80. Lovely demonstration.
I like Eric Dollard a lot, even though I think it was like yesterday or the day before. There was some people on Discord that were talking shit about him. And I'm like, why? Like, oh, he's a retard. I'm like, all right, well, whatever. I mean, look at his evidence, and but yeah, I've watched a lot of his stuff, but I have to look into it a little more. But yeah, that same kind of a concept is used in a lot of electrical tools nowadays, testing equipment.
Dude, he's even mentioned in Jerry Veslav's book being the only guy to replicate Tesla's patents, all of them. So it's like, why? It's like very interesting talking shit about somebody they haven't seen his work. It's like this guy transmitted through a Faraday radio. He transmitted radio through a Faraday cage on video. It's like, what's going on here? Yeah, like, and he told us how to do it. He's like, you want to make your professor lose his ear quick? Yeah, here you go. You know, take the Faraday cage with you, and I'll show you how to do it. Like, yeah, and he did it on camera, man, like twice. It's super legit. You can transmit right through the Faraday cage because you're going to the ground. You use the Faraday cage as the ground, and you transmit through the ground, not through the cage. Correct? Cage is going to stop all electromagnetic transmission. Fuck you, because I'm going to transmit through the earth, and you're going to pick it up just fine from the other side. Proven, like over and over. It's like, thank you. Tesla curves.
Yeah, and something else as well. When people say, well, there's grounding. Well, there's different types of, well, essentially two types of grounding. One is an earth ground, is a chassis ground. Sort of like your cell phone doesn't have an earth ground; it has a chassis ground. Same like with a car, has a chassis ground. So that's what completes the electrical circuit. But when it comes to a building, like a house, then you have an earth ground, and that's it's essentially the same thing, and that's where the difference of potential is associated with the actual. Okay, I'm going too fast. Potential is voltage. The difference of voltage is how you can determine what type of grounding system you need, the size of the wires, and things like that. But if you don't have any grounding system whatsoever, then what you have is an open circuit. You might have a potential, but you don't have the grounding system in place. So nothing will work if you don't have that.
I posted a video on those light bulbs we were talking about. It's a short one.
Oh, badass, dude. I didn't know they're short.
Yeah, and there's another one. Did you see the one where they reproduced? They used the ground as an antenna, and they were picking up China. You seen that one?
Oh yeah, 100%. Yep, 100%.
Yeah,
right through the ground. Of course. Have you seen the one he goes to the beach, right, and he uses the grounding plates out on the beach, and he uses that to transit.
Crazy stuff. Yeah, this is really amazing stuff. Another thing with this energy is you can like Wi-Fi. In other words, imagine now your phone, right, working as you're picking up Wi-Fi. It's like a battery. Also, it's transmitting power. That's what was his ultimate goal. No plugs, no electrical plugs. all machines run through this radiant energy, which is transmitted in the air.
That's how you can operate a burnt out fluorescent bulb. It still works.
Oh, yeah. He did that in 1890s. He did that in 1890s. He had a bulb, a fluorescent bulb in his hand, and he lit it. Through the air.
Yeah, of course. No, dude, when you're playing around with this stuff, that's exactly what you use as your detector. A big wand is like you just wave it through the air. It's like, okay, this is the electrical field. It's right here. Use it as your electrical field detector, and just glows where there's high intensity of electrical activity.
Yeah, you picked it up before. Like the crux of this is spark gap. This is how this all works with the spark gap you were talking before. He once said that he can transmit this energy across the Atlantic Ocean, and boats with antennas can use this without having any fuel. Never use fuel. Same with cars, your lawnmower, anything that uses electricity. He said that he was able to transmit that energy through the air. No wires needed. Imagine now. No wires at all.
Yeah, and you could also track enemy vessels using the same principles and get them locked.
Yeah, he had the death
There's
ray
no
as well.
escape.
That's another. Yeah. You guys heard of his death ray?
You can't hide from the base medium, son.
Bro, this guy had an open-ended vacuum tube, bro. A vacuum tube with an open glass tube. How about them apples?
Open?
Yeah, he's got a patent for an open vacuum tube. Correct. Yeah. He's like, oh, how could you have a vacuum tube? Tesla, bro. Leave it to Tesla to create a vacuum tube that's open at the end. I swear to God, it exists. And once you see how it works, you'll be like, no shit. Like, you like, okay, no shit. It's legit. It's a legitimate vacuum tube.
Well, how? How would it work?
It works on air. It has like so the open end, like let's say it's a cup. Around the rim, there's like a slot that you got high speed air that rushes, and it's pointed forward, so it creates a vacuum like the Venturi effect. It creates a vacuum behind that low pressure zone, and it starts this rushing air. The airstream, right, creates a vacuum for you inside the bulb, which is open to the air, which is interesting shit, man. Just look it up. He's got the patent for. You can look up the patent for it. Tesla's open-ended vacuum tube. Mind blowing. Because if you go into, so I think Vasilato's covers it too. So from his tubes, he was able to shoot the stuff at like a pendulum, different projectiles, rubber, wood, and all that, and he was able to move it through space. You know what I mean? By shooting it with this stuff that he was getting out of the vacuum tube. Later on, following the same exact apparatus.
Now, apparently, you guys correct me, you guys know more than I do, but apparently he was able to adjust this radiant energy and, for example, pass it through walls, heat houses, and stuff like that. You guys heard that one? Like heating without radiators.
The manifestations could be tuned depending on the pulsation width and frequency, like
Syrus
was saying earlier.
No wonder they made him crazy and he married a pigeon. Yeah.
Yeah, he made. So that they classify this as in radio disruptive discharge circuit. And if you do start playing around with this stuff, like, man, FCC is gonna hunt you down. It's very noisy in the
Apparently, and you
electromagnetic
guys will know
world.
more than me. Apparently, this was discovered when they shut down high-powered circuits, like at the switch. When you shut it down, that's when this white stuff. You guys know about that?
Yeah, that's on DC Navy ships kill people. 100%.
Yeah.
It's when you kill the power
Right.
doesn't, because it's the collapse. So it's all about this fibrous structure that's built up and stored in space around the wire. That's being the magnetic component. Then you have the electrical component also in space. And when you open circuit and you have high power under it, all this fibrous structure collapses now back into the wire, inducing this current, bridging the gap between your two wires, and it just grows and it kills people. If you're near that switch, buddy, goodbye. You know, this 5,000 volt DC stuff, they didn't know yet. Open the switch, you die. Close it, you're fine. Open it, you die.
Have you seen those videos where these guys work on these high capacity switches? They're like, they got like a spacesuit on, and there's another guy with a hook holding him. You ever see that
Fiberglass
shit?
rod. Yeah, bro. Yeah, man. Bro, it's serious. So we have like
What
vacuum
the heck?
switches for when like our power companies want to do some servicing and they open it up. I believe they do have they should have vacuum switches that open up the contacts under vacuum to snuff out this plasma, hopefully, that gets formed. Right? Because this stuff, if you leave it in free air, that's the magic. That is the parasitic stuff that Eric has got photos of it. I forgot which incident, and you can see it growing. It grows beyond the width of the gap, which is so interesting. This thing just grows in midair, collapses back, and buddy, something is blasting at the station. Transformer, or sometimes the entire substation. See ya. It's so much power that leaves nothing behind and people die. It just incinerates shit. It's massive.
Yeah, well, apparently, bro,
Amount of joules.
Apparently, that's the stuff that Tesla uses and is able to control. That cloud that you're talking about, that's what it's all about, apparently.
Yeah.
Yeah, it's the base medium's manifestations. But if you don't control it, see, the thing that makes no sense to me is why would they play with power and have no valve, no like safety feature? It's like they've been playing with
We
steam
don't know
engines
yet.
for so long. Then but you would think they would have some redundancy and some safety, but they're like institutionally retarded the way they design their whole systems. It's dumb.
You must understand that like you have physicists at the front of science, and they put mass to everything, and you're dealing with this massless invisible stuff that if you don't believe that it's going to kill you, just stick your finger in the socket, right? Like, dude, it's real, it's there, you can feel it, like it is not a joke. And it's like, all right, and so the physicists stay out of it and listen to Oliver, Heavyside, and the other guys. You know, because it's a massless thing, so they have no place in it. And then they're always trying to hop in Einstein and these assholes. And it's like, stay out of electricity.
Another thing you mentioned with this energy, right? Apparently, it's instant. There's no like it beats the speed of light type deal. It's instant communication, no matter what distance. That's what he said.
The background medium. If you're tuned, then why would there be any delay?
And we all know about his wireless boat that he did in New York City, right? We all know about that one. In the 1890s, he had a remote controlled boat.
There's a video of that, if I'm not mistaken. They got him on video driving that thing.
Okay,
Black
cool.
and white.
People didn't believe it. They thought there was a little monkey inside controlling it.
Bro, he was way ahead of his time. Radio control. He's still called radio control to today, you know. So what do you know? And he said
And
he
when he
moved way
died,
beyond that stuff.
yeah, bro. When he died, who took his stuff from his hotel? You guys know?
I do. That would be Donald Trump's uncle.
That's correct, sir. Yeah.
What do you know, bro? What do you know? Funny, huh? That's how the world
I'm sure
works.
it's a coincidence. Yeah.
What a coincidence, bro. Wow.
Oh, this might be helpful for Andrew. Tesla viewed voltage as streams of ether under various states of pressure. Raising these stresses could produce enormous ether streams, where the observed voltages would then be extremely high and luminous.
And apparently he can transmit this power. Like you can have your hand on the device and have your other hand, your other finger, let's say, on a piece of a metal. And apparently you can heat that metal and it can transmit through you harmlessly. That sounds freaked out right there.
Yeah, isn't there a similar thing with the hydrogen torches? You can put a hydrogen torch to you, it won't do anything, but to metal, the metal will heat up. Is that a similar principle, Syrus, or is it just sound similar?
What is exactly? I missed
What
that.
he said about you can heat metal without it affecting you. Is that similar to the way the hydrogen torches work? Because you can put the flame of a hydrogen torch to your skin, and it won't do anything. Well, let
I
me
don't
be more
know.
specific.
I was never ballsy enough to do that. That thing is hot.
Yeah, but you've
It's
seen it on
invisible.
videos, right?
I have hydrogen gas as an oxy hydrogen setup, for working with glass and stuff like that. It's very clean flame because the byproduct is only water, but my God, it's hot. It's like, I do not dare to put my skin there to try it out. Thanks.
Yeah.
Maybe it's bad on your skin. Like, I'm not sure. Maybe not.
Yeah.
Bad idea, I think.
Well, you could just test it with your gerbil or something. I found the part in Jerry's book about Eric though. It says it's impossible to comprehend Teslian technology, which is an interesting way of putting it, apart from the controversial topic concerning the ether. Many analysts will reject the concept without first seeking out and discovering the proofs which have been established by experimenters such as Eric Dollard. Nevertheless, the overwhelming evidence proves that Tesla has indeed been the first to identify gases with which Dr. Mendeleev had so long predicted. That quote travels well.
I don't know
Yeah,
if
I
you guys
like that
seen
one.
this last interview I posted. You guys might find that interesting.
Yeah, I'll post a screenshot of that particular quote, but the book is there. I posted the book, so people just need to read it. But, many of them never do.
You guys hear how he was able to visualize this stuff? You guys ever hear?
It's because he never had sex with a woman, so he was operating on peak performance. No, honestly, there's no way anyone's going to do what he did if they were busy dealing with a female.
No, but listen to this, bro. This is very specific, right? He said that he's able to build these contraptions, right, in his mind, okay? Make them run, and then come back later and see what's wrong and this and that. Like, I don't know if that's true, but I mean, this guy had like an AutoCAD in his head, like, or something. That's how he explained it.
Yeah, the power of semen retention.
It was he can run it in his mind and test the rate of bearing wear on the motors.
Yeah, bro.
It's like, what? Okay.
What?
That's the legend, bro. That's the legend.
But it makes sense considering the rest of the legend with his mom and what his mom was responsible for. It's like he had the perfect combination of familial lineage, because she was an inventor of just practicalities, right? Household goods and that. And his father was Wow. You know that story, don't you? I think the problem is most people's imagination has been curtailed by indoctrination, so they don't realize how powerful they can actually be if they just focus their mind.
How about the X-ray? He also invented X-rays. I think he called them cath. I forgot the name. I don't want to butcher it, but yeah, he had X-rays.
Non-destructive X-rays.
You don't want to talk about that. If there's Globers around, they're gonna lose their mind.
Yeah, we
What
do.
this guy was able to, they're gonna lose. You don't want to talk about that, bro. If you stand in front of a wall of X-ray tubes of the power of like 20,000 watts, like this guy, like bro, it's you would be cooked like immediately. The minute you flip the switch, you're dead. Okay, this guy, flip the switch, a wall of fucking vacuum tubes that are emitting X-rays at you. And just continuous, just keep it on. It's all good. It's like, okay, how? And yeah,
One
man,
of these
that's
things is not like the other.
bro. If you got any literature on that, please hit me up in the DMs. Either one of you or anybody that's got any literature on that, because
It's
that is
been a long
something I'm
time.
super interested in.
The only thing I remember from was just some quotes about how what he did was non-destructive, but what Edison did killed his assistants. And you're like, well, clearly
Yeah.
these guys are operating in different fields. And it's the same with Marconi. Marconi wasn't doing the same radio. Radio waves was Marconi. Tesla was doing impulses. The
Bro,
transmissions
I'm
were
telling
different.
you, he lined him up on a wall, bro. He lit up the whole wall with extra, like he's like, dude, like an array of tubes on a wall, and you just light them all up at once of X-ray tubes. Dude, you are going to the grave. You know, not this guy. He was able to do that and somehow live. It's like,
Yeah, Syrus,
okay, what kind of sauce do you have in the tubes, man? Like, what is this shit?
Read what I just posted there, bro.
He
You're
became
gonna
the
like that.
ground. Maybe he made himself the virtual ground. Who knows?
Some.
But remember, a lot of his stuff was to baffle. Like he was doing performance art after a while because people didn't know how to interpret it. Right? They were still thinking AC/DC.
Yep.
He's like, well, I'm not doing that, but I'm gonna not dissuade you from your misconception. Have fun.
Professor Parks, if you're there, look at the other picture I posted.
Yeah, bro.
I know
10
that
million
looks
and
like
12
cartoon.
million volts. That's what's up, bro. That's Tesla voltage. And don't forget,
Is that
you know, like
crazy or what, bro?
well, he had Westinghouse alternators at his laboratory, like 3 of them. So he's got generators that generate enough electricity for the city, you know, and that's in his laboratory. So yeah, he has access to insane power, dude. It's like, all right,
that's where one of Dollard's videos is important because he was able to demonstrate how you can convert from this one system to the other system.
well, actually, I think Dollard is a genius because the analog computer. I think he pushed that for like, so you can build a simple circuit, or what he calls an analog computer of all this entire network on your bench, and he demonstrated this that you will get the same effects that you can get with the Tesla coil with this analog computer. And it is so simple, it's unbelievable, and it works. He demoed this shit, and he's got it in his papers, of course, analog computer, and that's where it's at. I think Dollard actually summarized all of this too, right? Where how to do it.
Sorry.
Yeah, go ahead.
What do you mean? What do you mean analog computer? How are you tying that up?
You're gonna have to elaborate.
It's Google Eric Dollard analog computer. That's what he calls it. Okay, so what it is so you do an analysis of this entire, so all this stuff when you open the switch and this people are dying and all that. You're going to take this entire electrical grid, right? You have capacitors and or inductors or resistors and capacitors. You got capacitance between nodes and like inductive loads, people like consuming power and stuff like that. So you build a series of these inductors and capacitors on a bench, and at the end, right, you get this Tesla electricity that he's talking about, and he demonstrated this because what you have there is a miniaturized grid, electrical grid, and bro, he used an audio amplifier and he tunes into it, so to the right frequency, and you'll know when you get, because you use simple stuff like your fingers and a light bulb, but watch out with your fingers. High voltage, you might get shocked, but you will. But with a simple light bulb, you can figure out the resonant frequency of that analog computer you built, this microgrid on your bench. And once you're at the resonant frequency, the bulb is going to be the brightest. And then you can start analyzing each node of the circuit, and you'll see these effects that he's talking about. He does this on camera too. So of course, he's mentioned in Veslato's book. He's not, bro. He really did a demo of this shit. And so analog computers. That's what he
Check this out. I forgot about this, bro. Look at the picture I just posted. You ever see that in Egypt?
Yeah, that's ancient Egypt. That's the sky and the stars, right? The
Yeah,
world around us.
but look further. What do you see her holding? It's like a gap, a spark gap.
With the Ankh?
Yeah.
Hold on.
Yeah.
Well, yeah. Have you seen? Yeah, I'm hip with the ancient Egypt stuff. The jet pillar. If you look at Google electrical insulators, like high voltage electrical insulators and jet pillars, these things exist on utility poles. These white porcelain thing. It looks just like the jet pillar in ancient Egypt. I'm like, interesting. Insulator? Like, what is this? It equals electrical insulator in my mind. But anyways, that's different stuff. Yeah, I love
Look
that
at the
shit.
Ankh you were talking about, bro. Check out what I posted.
Yeah.
I'm telling you, these Egyptians knew way more than we think.
I know, man. Same here, bro. I'm with you on that. Have you seen the boxes they're carrying with snakes? How about that? And the boxes with many snakes? And the batteries? Oh, dude. Yeah, the boxes, bro. Boxes with snakes, and then you got boxes with many snakes. I'm like, many volts. I see. One snake, 1 volt. Many snakes, many volts. Don't touch.
Don't forget the trident, or the Vajra, I think it's called.
If you wanted to convey something to the future, like if you wanted to draw it on the wall or something of electricity, volts and amps, what are you going to draw, dude? To explain what a volt is without using like literature, like this is what a volt is in mathematics and stuff like that. You're going to use, hieroglyphs and shit. How would you explain a volt? I'm going to go with snake. I'll take a box with snake. 1 snake, 1 volt. 2 snakes, 2 volts. We'll go from there. Maybe a snake is 20 volts. I have to figure that out. But
a cobra is 20. A cobra is 20.
The cobra is 20, right? Some boxes have like 8 of them lined up. It's like, oh, that's a 100-volt battery. Just careful with that one.
Yeah, I posted one of his old videos. Apparently, Lindemann was working with him. I didn't realize that.
Yeah, they were. They were in the videos together. Him,
But I didn't
Tom
realize
Brown.
it was from that old. I almost forgot.
Well, Tom Brown escaped to New Zealand. He was the editor-in-chief of Borderland Science magazine.
Yeah, that's the one that I'm doing. It's the Borderland video, the one that I posted.
Yeah.
It's super old, but I think he creates some kind
Lindemann,
of
Brown, and
at the end of it, he creates some kind of what would you call it? Luminous manifestation within a vacuum tube or something.
Well, if JJ, our friend JJ Thompson, of course, he had a paper on the appearance of what was it? Is it hydrogen on neon in vacuum tubes? Something on neon. Don't quote me, but if you Google it, you'll get the exact paper title. It was on the appearance of something and neons in vacuum tubes.
Yo, Syrus, if you look at the picture I posted 20 past the hour, right? I just realized this. Look at her hands, right? She's got the 2, we'll call that the spark gap. But look at the grounding. Look at her arm, her left arm. It's touched to the ground. It's like a grounding, bro.
Yeah, but you see that air gap, right? In between, that's the capacitance that we need. That's that spark, right? That's the plates.
Yeah, bro.
Well, have you seen the electrical symbol for a capacitor? It's this air gap between two plates, bro.
Yeah,
So,
bro. Yeah, it's crazy,
you know
man.
what I mean?
It's crazy. Yeah.
Yeah, dude. Other circuits too. If you analyze it, bro, have you seen the ones like with, the famous ones with the light bulbs, the light bulb of Dendra, dude?
Yeah.
Follow the bulb, right? There's a wire coming out of the flower, going underneath them to the pillar. It's a complete
Yes.
fucking circuit,
Yes. Yes.
dude.
Yes.
It's like, wow, it's a complete circuit, assholes. Like, why did you have to draw it this way? Like, why?
Yeah, it's crazy, bro.
It is.
So maybe they were using some sort of levitation. Our Egyptian compatriots lifting these 20-ton freaking boulders. Who knows?
Man, yeah, bro. It's like, if the idea is like, if the speed of light and it's the byproduct of the electrical conditions, if you figure out how to manipulate it, well, then perhaps gravity too is due to these electrical conditions, and you can just, well, let me just turn this off. Oh, okay, there we go. No ohms. Turn off the 377 ohms. It's like it should have zero friction in space theoretically, or go to J.J. Thomson's. That's why I'm a big subscriber of his, because he theorized that you can't, when you hit the brakes in your car or you try to slow it down, you can't come to an instantaneous stop because you have all these Faraday tubes or electrical lines of force, aka capacitance. You're between the car and the environment. You've built up charge, so you need to discharge it, and that takes time. Okay, but if somehow, and this is how we go back to Tesla's tertiary coil, if somehow you can disconnect the body of the vehicle from the electrical world around you, the electrical medium. Okay, now if you're net zero, so if you're neutral to that medium, he theorized now when you touch the brakes, okay, you should come to an instantaneous halt. Boom, and turn right, 90 degrees right, and you don't have inertia, like the forces, no force, you don't feel any of that in this electrically neutral vehicle. And I think this is why JJ then, I forgot who picks up his work. Thomas, I think Townsend Brown, with this electro-levitation stuff, essentially, and succeeding. But of course, it gets classified. It is classified Navy stuff, so we only know a little bit about it. But we do have a picture of them celebrating with this disc in a vacuum chamber that they were able to levitate using, because it's in a vacuum chamber, so it's non-ionic thrust. Okay, because everybody's gonna say, "Oh, this is ionic thrust." Not these guys, and it is classified, so that's all we know. A picture of them celebrating their success of non-ionic thrust in a vacuum on a disc, on a saucer. This does exist. This is after Thomson, Mr. Townsend Brown. So yeah, this is, I think, why they don't want us to go with this electrical theory stuff, because it opens up a lot of doors. Like how to levitate big stones or something. Just disconnect it from the electrical world, bro. Easy, right? Well, in theory, how do you apply that shit? Like J.J. Thomson, bro, he got the Nobel Prize, man. And this is why this guy is theorizing, discovering the electron. I'm gonna subscribe to him. You know what I mean? Like, he's mainstream. I'm giving him a subscription. Perhaps that's the key.
Well, J.P. Morgan saw to it that this technology would not see the light of day. And he was successful. They blew up his laboratory. They did all kinds of shit to him. Yeah, and they suppressed all the tech. At one point, I think J.P. Morgan bought all the not brass. What is it? Oh man, what's the wire they use to transmit electricity? Copper. Yeah, copper. Apparently he bought all the copper in the States. Yeah, J.P. Morgan. In other words, so he can control the transmission, right? Like, yeah.
Bro, he was funding AC and DC. This guy knows what's up. Somehow he just, if you follow the story, because Edison is not okay. There's levels to the Tesla story. Okay, this is how you kind of know where everybody's at. If they go Tesla good guy, Edison bad guy, you know they're at the level one. Like they haven't dug in yet. If once you're at the actually when you read it yourself in the newspapers, it was Tesla versus Einstein. Congratulations, now you know, because after the Chicago World Fair, bro, AC took off. Edison was kind of left in the dust, and they were just. They brought in Steinmetz from Germany and all that to start reverse engineering Tesla stuff. These guys were ahead. These guys were second. It was settled already. There was no real competition between them after that.
Yeah, they say
was done.
Heavyside fixed all this stuff, but that's not well. He did, but Tesla already knew all this stuff, and apparently they were fighting at that stage. And at one point, he stopped sharing his info with them.
Who,
Have you heard about
Heavyside?
that? With like when he was warring with J.P. Morgan, then he found out that hey, these guys are against me. Yeah.
Tesla, right? I've heard about that for Tesla. But yeah, J.P. Morgan, he's the one that funded Edison in the beginning, and Edison burned down his desk because there was like before the insulated cable came along, and it came along the insulated wire because of lobbying from the gas company. But before that, like the first house to be electrified was J.P. Morgan's house. So it was Vanderbilt. It was I forgot which his name was, but it was a Vanderbilt guy that was funding Edison and with J.P. Morgan, but the Vanderbilt guy for some reason I forgot. You can check it in a book called Empire of Light. He stopped funding him or something like that, and it ended up J.P. Morgan funded him, and his house was the first house to get electrified, and because Edison ran the wires in for his desk lamp in the leg of the desk, and it was not insulated or anything, and it caught fire and burnt down his library. But he still funded him somehow. He liked the idea, even though it didn't really work in the beginning. His library got burnt down because of Mr. Edison and all that, and he's like, okay, still give him the money to make it work, refine it. But it was later when Edison was a competitor to the gas company, because that's how everybody was getting their heat and lighting, natural gas. They lobbied to make him put the wires, all his overhead cables underground. And when they did that, that's when he invented the insulated wire, the Edison tubes. Or it's a copper tube, and he poured tar around it and a big tube. And that was the first insulated wire. So Edison wasn't a bad guy in the beginning.
Well, he found the filament, right? The right filament, because all the other filaments were getting burned up and stuff. And he experimented with all kinds.
Correct. Until one day he was staring into the fire and he got inspiration by that, because none of the elements that he tested worked. Everything when it got to white hot, it would just melt. Then by looking into the fire,
tungsten that he found? Tungsten? Was that it?
Bamboo. No, tungsten wasn't discovered yet. Bamboo, bro. Carbon.
Oh, okay.
So he went and he cooked some bamboo fibers after that, because he was like, carbon wants to naturally go white hot and is strong enough to still hold its shape together. So it was carbon. It was a carbon filament at first that made it feasible under vacuum.
No kidding.
Yeah. What do you know? Partial vacuum in carbon. I'll be right back.
So it took him that long to realize what he's trying to replicate is the answer.
Yeah, but he was stupid and he married a pigeon. And the real dummy, Einstein, they propelled him to genius. How it works is crazy, man.
Einstein never did anything. He just said stuff.
Elijah, carbon arc lamp is different. You talk about Edison. No, he was not trying to replicate the carbon arc. Carbon arc is nasty. Emits
Oh,
tremendous
that
amounts
wasn't
of
what I meant.
ultraviolet.
That wasn't what
Okay.
I meant. I was kind of being a bit flippant, but they're trying to replicate a candle, right? The answer was there the whole
Yeah,
time.
but an electrical candle, sir, and the gas company did not like that. What do you
I
mean
know, but you
electrical
see,
candle?
but you get what
No,
I
no,
mean,
no, it's
right?
a go. Yeah,
You get
yeah.
what I mean, right? They're trying to replicate the
Now I
candle,
do.
but the answer to the replication was in the candle, and it took him a while.
So, yeah, it had to be, bro. You gotta try out all the materials known to man and fail. And then one day you're just looking into the fire and you're like, oh, let me try carbon. Good job.
Bingo bongo.
And it works. And then
And
when we discover tungsten and we still use tungsten, it's like that's it, right?
nothing new under the sun.
Well, tungsten came out after that, and apparently after tungsten, there's nothing new, I guess, until something else. But I think we're done.
Now we've just got abominations and pseudo facsimiles. Disgusting. LEDs should be smashed to pieces.
I'm not a fan. I use them, but I still like real light, like a tube, some sort of discharge lamp, a real lamp, where you got plasma formation inside the bulb. It's like that's what I want. Plasma. I don't want fake plasma. I want real plasma. Cold electrical fire.
There's one thing we didn't touch on, and I'm surprised with Tesla. You must be familiar, Cyrus, that he claimed that he can harness radiant energy that comes from the sun and from space. And he even has a patent on that. You aware of that?
Yeah. Yeah. And his receiver, if you don't follow the primary and secondary like how he has them, it's never going to work. And he's talking about a receiver for that beaming, that stuff that you can just beam from transmitter to receiver. It's like this highly ionizing gas. It's like, yeah, it works. It's like the same principle. So if you build one of those, which people have, and you're trying to get DC or AC out of it, well, it's not. It doesn't really work, bro. But it's for this radiant stuff. Yeah, it's a receiver of the radiant energy. He was
I
working
think
on.
it's a plate that he had in front. I'm trying to find it. It was a plate, right?
The fan? Yes. Yeah. Yep. Yeah. You know the fan. That's correct, sir.
Crazy, bro.
Very
Crazy.
simple. Very simple device. Primary, secondary. I think in the plate. Super simple. So you built that. You're like, dog. I'm not charging. It's nothing. But yeah, because you're expecting DC or AC, but it's gathering radiant energy, and your devices aren't running on that. So there's a conflict here. Trying to put diesel in the gas motor.
Hey, SE. These atmospheric charge density things. The problem is, yeah, you have a big voltage potential, but the charge density is incredibly low. Outside of a thundercloud, you just can't produce any real usable power out of that, right? And
Yeah,
even with
wrong.
thunderclouds, right? You get lightning bolts. Like a bbig lightning bolt might have almost a megawatt hour of electricity in there. It's very hard to harness that because it's the charge density of the masses all at once. It's just not very usable.
The worms are popping their head up, Cyrus.
Yeah, there's a conflict, but it's he was addressing SE, so stayed muted. There's a conflict of interest
Sorry,
here.
I missed that. Sorry. If you were addressing me, I
Oh,
missed that.
I was that old article where they were measuring this high voltage potential in that old article of yours.
Yeah.
That's like a known thing. Like people have done some pretty cool tests, like making big sparks with like a drone pulling a wire up because there's this big voltage potential when you go up in elevation.
Right.
But the
Yeah.
charge density is so low, you can't do any usable work out of that because just your coulombs per square meter of charge is just so incredibly low. Outside of a thunderstorm cloud where you have at least a reasonable charge density buildup, you just can't get any reasonable power out of that. You have a lot of voltage, but you can't carry any current at all.
Oh, I see what you're saying. Yeah.
It's not some conspiracy to block it. It's just not a usable way of extracting energy from the environment. It's just not. It's just not concentrated enough.
Yeah, but you're not quoting anything these guys built. Like, this is cool. We understand charge. We're talking about the electrical gradient in the sky, but this has nothing to do with the conversation.
Yeah, this
Because
is different. Yeah.
There's many people like Thomas Henry Murray, T.H. Murray, Dr. Murray. Look up his antenna. Okay, he's 80-foot antenna, pulling like 50,000 watts. His magic black box was reviewed by many people, right? Well documented, pictures and all, sucking power somehow out of something, tremendous amounts of power, with an 80-foot antenna, ground wire, and this box of electronics, right? So, anyways, if you don't know about the guy,
Well, this is not
I just
the
don't believe it.
germanium is a semiconductor. You don't believe it yet, but there's evidence for it.
I think it's the same as that guy that had that fucking car that he claimed had a carburetor that got like 150 miles per gallon. That was just a total scam, also.
The energy we're talking about here is not the potential between, when you go up in height. We're not talking about that. Tesla was talking about energy, radiant energy that comes from the sun and from space itself. And he built apparently an apparatus that can harness that. That's what we were talking about.
Yeah, we make those. It's called solar panels.
No, bro.
You got a You got a kilowatt. You got a kilowatt of power for every square meter on Earth. It's pretty good. Pretty good.
Does work at night too.
Yeah, this works at night. That is correct.
It's not
It works
photovoltaic.
in a dark room. Not just
Doesn't use photons to do anything.
I think they're just rumors.
Yeah, it's like talking to a
Or
different
scams, or just outright scams, like the guy that had that bullshit carburetor.
You're historically malnourished. Why don't you go and read a book?
I don't know whose carburetor you're talking about.
I posted a picture of what I'm talking about. Have a look. This is one of his patents. Has nothing to do with solar panels.
Solar panels are big gay.
Told you there's a conflict of interest here.
It's conflict of comprehension. You
That's
don't
all
speak
good, man.
the same language. You can't understand me.
Just
the
like
guy I was
Dollar
thinking
said.
of, his name is Tom Ogle. He was another scammer.
See what I posted, Jay?
Vapor carburetor.
Rob, your mom's a scammer. You're not even real. Go away.
So let's see. Well, back to what? What were
Yeah, I've
Tesla
got that
radiant
one.
energy?
That one's in
Yes.
the book as well. Let's see. Why does it post the wrong one?
It's crazy stuff, man. If true, I don't
Well, then
think
if you
anybody
keep,
ever reproduced this one. I don't think this one has ever been done.
yo, Elijah, have you read the book fully? The Lost Science?
Yeah, like not in one sweep, but I've done focus
Have you,
sections and stuff.
did you get to? I
The
think
one
he's
that I
got a
found, the one
chapter
that
on
I found the
Dr.
hardest,
Murray.
the one that I found hardest was the harp stuff, because there was so much to unpack.
Oh, that's
But
a
go
great
ahead.
book.
Sorry,
Yeah,
what was your question?
about Raymond Royal Raymond Rife. Did you get to that guy?
Well, I know about him, but where's he? Where in the book is he mentioned? I might.
Oh yeah, it's after Tesla's chapter, maybe by a couple of guys or so. He's in Lost Science. He's the guy that was with an optical microscope. He saw viruses. He was able to capture viruses, and not by using. He'll highlight this, Mr. Veselatos. He was not using radio, right? By using Tesla currents, and by tuning into the frequency of the virus, he can kill it while observing it because it's an optical. It wasn't using the scanning electron. You got to have a dead sample and metallically coat it.
Oh, that's another one, bro. I forgot. Good on you. Yeah.
Bro, he's
apparently
a gangster.
you can kill germs. Yeah, man.
Yes.
Yeah, apparently you
Yeah.
can kill germs.
So would that
Yes,
be
sir.
in chapter 3 or 4? Because you got chapter 3.
That's like chapter. Keep reading. Okay, go ahead.
Well, chapter 3 is after Marconi, right? So it's superior.
You start
directives and military research.
No, the first chapter in the book should be about Baron Karl von Reichenbach. Okay, Reichenbach.
Maybe it's a different. Maybe it's a different.
That's he's going to start. Yeah, that's Lost Science, the complete edition. You start for chapter 1 will be about Karl von Reichenbach.
I
and
had
he'll
that. So I don't have
introduce
that on
you.
this phone.
Bro, you have to start from here, bro. Because this guy had money and he's not a nobody. He discovered like paraffin and dyes in Germany. He is not a nobody. And see what his discoveries were.
I remember
Amazing.
what you're talking about now. I focus more on secrets of Cold War technology. No, I need to read that
he goes
one
to
more thoroughly.
Yeah, then I think after him he goes to Antonio Meucci, the true father of telephony from Italy, with his Earth-based telephony, right? And then Nathan Stubblefield again with his Earth-based stuff, and then I think he'll get into Tesla a little bit later. But he'll introduce you to several different guys before and then after.
Right, so you're
And
talking
one of
about
them is
you're talking about his whole discography, the books that all the books that he's done.
no. That's I think there's it's called the Vril Compendium, the 11 volume. No, not that one. That's what I'm talking about. Is called Lost Science by Jerry Vaselatos. That's the book.
Yeah, that's the
Lost
one that I've read
Science.
the least of, but I need to re-download that because I've got a new device now.
Oh, dude, that one has a lot of. It's juicy.
Thanks for reminding me. I would have forgotten.
It shuts down this whole virus stuff. It just ends it. This guy optically observed it. It's like done. You're live. It's like, all right, cool, sweet, and he can kill him with Tesla currents. What you can call colloquially radio-free RF, but you would be absolutely wrong. And Vaselatos will highlight why you would be wrong. Yeah, dude, Dr. Rife with his microscope, badass. You can go see one. I forgot which museum it's in. We still got a couple.
Vaselatos. So, but isn't that where you have to then pass out the distinction between how people talk about virus now and what you're talking about? There's a distinction because the definitions overlap, but the words are the same.
I guess this very small microorganism, whatever you're gonna call it. I think they call those viruses. Is what they're talking about.
Harris. Well, no, because
he found, according to his findings with his microscope, every cancer had this same exact virus. Every cancer cell he checked out had this virus around it, and he was able to kill it. So every single sample, he said. So he said cancer is a virus, which is like, what? Okay. But anyways, bro, dude with a microscope. So I will take his word, and he was able to kill it. I'll take his word for it.
So you think viruses are living things, yeah?
Yeah, of course.
Yeah, I told you this was going to happen.
Okay.
You have to pass a different
I
sound.
just
according to
want to check if you're
Dr. Rife.
seriously that stupid or not.
No, Dr. Rife. So photographic evidence of this, Royal Raymond Rife. He's whatever this is. Yeah, he's the authority figure on this.
Yeah,
Do you know the difference between bacteria and viruses?
Yeah, just read the works of Dr. Rife and holler back at me. Let me know what you think.
So it's chapter 5. All right, I'll find it and I'll post some pictures.
Some people get really mad about this.
This gets into the naming convention issue, man, because people the language has been abused over the centuries.
Yeah, whatever. I like it.
No, but that's why people aren't going to understand what you're saying, because they'll get triggered on the
Microorganisms. You want to just label it microorganisms and move on, and determine it by micron size,
no organism.
how big it is.
Well, that's exactly the thing. A virus is no organism.
It's a program, a machine, whatever that is. I'm talking about microorganisms. Talk about living microorganisms.
Another thing, bro, I'm remembering all these things now. Syrus. Another thing that this stuff did when he turned it on, it kind of created a good mood. It was like a happy, like a drug kind of a thing. You heard that one?
Yeah. You heard the one where he slept under it for 3 days? This guy doesn't sleep that long. 3 days, bro. Yeah. That's awesome.
Yeah, there's a lot to this, man. A lot.
All that, I think he ends his Lost Science, but of course, the man himself, Mr. Philo Farnsworth, with his electric fuser. Of course. All electronic fusion.
Are you talking about nuclear?
No, not. This is not conventional. So it's just again Vacillados, the same book. I think it's the last chapter, chapter 9 or so. And he ends with him, Mr. Philo Farnsworth. Same thing with Eric Dollar. Funny enough, this is where sort of the electrical tube research ends, and the last stuff, the end of his life, he's working with the Navy classified stuff. That's the end of that. Because he's the only guy, according to Dollar, he's the only guy that understood what an electron is. Actually understood it, right, and manipulated it. He did stuff with it. So he's like, and he wrote no books, and he's dead. I'm like, oh, sweet, okay, awesome. But yeah, he's the one that gave us all electronic television. As it was mechanical television before him.
You're talking about the cathode ray?
Correct, yeah. Yeah, how, you have to scan how many lines, I mean, the electron beam needs to scan. That was done mechanically, the rastering process. I think that's what it's called. Some shit like that. So, yeah, these lines that the beam would go across, he did it electronically, all electronic, which is the tube television that we all know. But before him, it was mechanical.
And the mechanical one was called how?
Was called what? Called mechanical television, mechanical tube television.
Mechanical television. Can you post any evidence about that thing?
Yeah, of course. They had a spinning wheel, I believe, inside the tube or something like that. You can look up older patents. That's pre-Philo Farnsworth.
Yeah, sure. Post it.
Oh, why do I have to go do homework? I'm very confident
Because
of
you're
what I'm
just
quoting.
bullshitting about stuff that never exists. Doesn't have to
You-
do anything for you, bro. We're
No,
having a good
bro.
convo. Don't
Yeah,
spoil
it's
it.
all good. It's all good. You know, okay.
The lazy
You know about magnetic?
incredulity.
Do you know about magnetic
Once again.
deflection in a CRT in the cathode
I
ray
know
tube?
how a cathode ray tube works, yes, but there is
Okay,
no
cool. So
no such a thing as a mechanical television.
there's no such thing. Okay.
No, cathode
So
ray
what
tubes
was it?
are cathode
What
ray
was it
tubes are
before it was
older
electronic?
than the technology to make visible pictures out of it. For example, an oscilloscope or visualizing signals is something. But then using this technology to create pictures was a new invention of actually like the TV. But there was no such thing as a mechanical television before.
How was the rastering done? How did they do it before
Like
Philo
magnetical. That's what's called the brown tube, the CRT.
Okay.
It has a horizontal and a vertical deflection with magnetics, and that's how it works. How it worked all the time.
All the time. Okay, cool.
There was no mechanical predecessor or something like this.
Bro, there's a Wikipedia page on it called mechanical television. Like I don't. I mean, whatever, bro. Cool, man.
They just can't
Before the
handle the
electronic
normal
deflection,
conversation.
they did not deflect it electronically. Like, go.
I found the relevant slide. I mean, obviously it's a whole passage, but I'll just post it. I'm referencing the Dr. Rife stuff just in case.
Mechanical scanning methods were used in the earliest experiments of experimental television systems in the 1920s and 30s. One of the first experimental wireless television transmission by Scottish inventor John Logie Baird on
But
October
it was
2nd, 1925.
that was a completely different
Mechanical television
functional.
existed.
That was a completely
So
different
many.
function. It's not like they had something mechanical in the television in the back that moves the electron rays. Anything that works.
How
with
was the
electrons,
scanning done? That's why they called it mechanical. How was the scanning done? You
not
had
with
lines to
electron
scan
rays.
with the beam. Okay,
Yes.
tell me before that, what was mechanical scanning? That's what they call it. How was it done?
It was a spinning wheel.
Patents. There you go, a mechanical spinning wheel. Okay.
Oh God!
I just
forget
posted it.
Go on.
I
Go
just
on.
posted.
I thought.
I thought I put it.
I thought
You
I
see?
said mechanical.
No, you did. They just.
Anyways,
It was a
Wanna
wheel.
disagree,
That wheel
go on.
had specific holes in it, and through these
Just
holes
like
you
your
can
old
look
mouse.
to a lamp. So you're looking through the holes to a lamp, and depending if the lamp is on or off, you can see a pixel or not, and the timing of the lamp. There was no rays, kind of electron rays projected to some kind of screen. You're looking through a rotating disc that has different holes in it, and depending on the timing,
That's mechanical.
of the
That's
backlight
mechanical television.
and the holes. Yeah, but you were claiming that there is some kind of mechanical moving thing that does the
The
scanning.
spinning disc, the spinning wheel.
Okay, then you just explained it poorly.
I did. Okay, whatever.
Cry
But
about it.
who invented that? The all electronic television? You said Brown? No. It's Philo Farnsworth III. Wikipedia, of course, him, and do you give him credit for it? He's the inventor of the all electronic television. Straight up. Non-mechanical. Electronic rastering. You scanned it. Deflection. That's yeah. We should be the last chapter, if I'm not mistaken.
All right. I'll have a look for it. See if I can post
Mr. Philo. Because then he gets into electronic fusion.
Oh man, he's got all the press clippings at the end. That's awesome.
It's good shit.
All right, is that no? They're his. Ah, they're his other books. Bloody hell! How much is? Oh, it's a combination of things. It's like citations, his own books. Does Jerry still produce stuff, or is he mainly just chilling?
I'm not sure. I do not know. The Nipkow disc, patented in 1884. Very good. There's your mechanical television. Yeah, CRTs go back to Sir William Crookes. Pretty old.
Mind and Fire and Thermodynamics. It's not that chapter, is it? Must be before.
Just scroll through.
This is a little thing on
Yeah,
the.
okay. I found it.
Nice.
I posted a thing on him talking about the cosmic rays we were talking about before, not solar power.
I mean, it takes some serious hubris to deny that which is the necessity for your own existence. It's like saying, "No, I don't have a dad." Okay, dude.
No, but imagine all the magnets, the coal, gas, oil dudes, when they hear a thing like this, they must have went crazy, right? What? He wants to give free energy.
Right, the love of money, the root of all evil. You must master it. You're not supposed to love it.
Yeah, clearly a man ahead of his time, clearly a genius, and clearly they did everything to block him, including making belief that he married a pigeon.
Bro, he just made some solar panels back in the day, bro. That's all he made. Relax.
Yeah.
I heard he didn't marry that pigeon. He only had a one night stand with it.
Yeah.
And then he flew the coop, yeah?
And a real bonehead who couldn't even speak properly without reading Einstein, they made him the genius. Unbelievable how this works, man.
He invented radio.
According to what's his name, they were all retards,
transmission.
right? I see.
What's that?
I said, according to what's his name, they were all retards, according to him.
What's his name?
You know, the guy that doesn't believe in viruses or diseases.
Right.
The one that said you wouldn't go to the hospital if you had a ruptured appendix.
It's always funny that it's like the people that believe the space program are actually getting fleeced by the space program. Took a fucking medical experiment drug for some fictional virus, and then they want to pretend that they have like